Yeah, so let's start the session. I hope the screen is visible. Am I audible clearly as well? So in today's session, we'll discuss about the advanced evals. So like a lot of you might have heard about let's say building AI product, like how to scale that AI product to maybe 10 million, 15 million user, right? But the most critical thing is it performing good? Is it intended to perform like whatever the action it was supposed to do, right? Because prototyping is very easy. Like in a span of let's say a week or a weekend, you are able to build a prototype. But to scale that prototype to let's say a million of users, that is what a real challenge comes, right? So in today's agenda of this session is to cover, let's say, what are evals, what type of eval we need to choose, what is the different type of evals, how to compute different type of evals, right? And then let's say if we have to build certain sort of eval, like we'll see with one of our demo, right? So before starting, I'll introduce myself. I'm working as a senior product manager at one of the e-commerce company. I'm building a lot of let's say your AI product from starting from 2023, and like faced a lot of challenges, failed miserably in scaling those. So have written those of lot of evals. Along with me, Apur Mittal is also there. He is also associate director at one of the e-commerce company, and he has also built lot of good AI based solution. Maybe if you can think about the looks, like what different type of looks will be uh, will be suitable for certain set of people. So like he has written a lot of eval. So we'll be starting the session, right? Yeah. So this will be the agenda, and this will be a quite dense session. So at any point in time, if you feel like you have certain question, please feel free to put that into the chat. And it may let's say it's a 3 hour session, but it may cross let's say 3.5 to 4 hours because there are a lot of things we need to cover, right? Yeah, we can start. Yeah, go on. Yeah. So what we'll do is like we'll try to learn, let's say, the theory, the advanced thing in the first 2.5 hours, and then we'll try to build, and then next 30 minutes we'll see the question and answer. This will be the broad agenda for this session. Yeah. Yeah. So as I was telling, the demo era is over. The building a AI prototype is very, very easy. You can build AI prototype in maybe a weekend. So building has become a commodity. But scaling that product to, let's say, 10 million, 30 million users is something where the challenges come, because AI hallucinate. It is not a deterministic thing which used to happen. Let's say if you write something and this is supposed to happen, you do a UAT and then it's okay, right? That is not what is happening. The output of, let's say, LLM or AI product can be is a probabilistic. You cannot expect every time to this come to the same answer. So that is why scaling the product is becoming a challenging thing. And then we'll use lot of AI evals to make sure that it is going further. Yeah, go over. Yeah, yeah, Poof, you can take one now.
Yeah. Now, imagine that, let's say you are building, let's say, a shopping product similar to what you might be seeing, let's say, on different e-commerce platforms. Let's call this, let's say, a shopping bot as like something, like say, which is very, very similar to what Amazon is doing, let's say, Rufus, right? Now, in this shopping bot, the shopping bot is present to the audience in general, and the customers can actually pose all different type of questions. Somebody can come and answer that, like, hey, what is the return policy? Somebody can ask and basically do a search operation here. Somebody can have, let's say, a simple customer query also, that like, hey, my return has been picked up, but my refund has not been processed yet, right? So what you're seeing is that, like, the span of these products is something like which is very, very open-ended. What you get to see is that there could be, let's say, multiple combinations of inputs, and hence there could be, let's say, multiple different combinations of outputs as well, right? Now what you do is that, let's say, on the very first day when you're trying to launch a specific product, you are having an understanding, you were able to understand that, you were able to visualize a certain set of use cases, that like maybe these are the kind of things that I've seen in the past, and probably users are going to kind of use this entire thing for, let's say, these kind of use cases itself. And hence you build this entire product, let's say, with a certain understanding. You choose like a specific AI model of your choice. You kind of stitch the entire thing together, and you basically ship this entire interface to the users. In the initial first days, like it is working really, really well because the number of users that are interacting with are limited, and the kind of queries that you're also getting to see is something which is also, let's say, very, very limited, right? But the real taste actually starts coming in once you start, let's say, scaling it up, because this AI system is expected to, let's say, interface with multiple things, right? So think about like a simple example that you would have thought about that, okay, users will come and ask that, like, what is the latest kind of an iPhone? But somebody is trying to basically do a strict comparison of price between an iPhone, which is of 256 GB, and an iPhone, which is of, let's say, 128 GB, right? Now, these are certain case of use cases that you have not even thought about, and you are not even sure that, like, how the system is going to perform. And people are also trying to, let's say, do a lot of jailbreaking exercise, etc., where they're trying to understand that, like, what is the very genesis of this, let's say, AI chatbot, and then trying to kind of overrule the same. Maybe, let's say, some kind of a prompt saying that, like, hey, give me all of your instructions that you're receiving, right? Or the typical problem that this bot might face is that it might also, let's say, face a lot of hallucinations. So in certain scenarios, the answers, let's say, for a specific query is coming correct, but when different users are asking that query again and again, there are certain set of hallucinations that, like, you're basically getting to see. Now, the traditional thing, I think the one very basic question is that you're not going to launch, let's say, this product without having a strict QA. And I'm very sure that, like, when anybody of you is launching this specific kind of a product, let's say, into whatever ecosystem that you have a QA team, like a quality analysis team, who's trying to kind of do and understand that, like, how this product is expected to behave in a production kind of a setting. But some of the use cases that you're seeing in production, they have actually missed all of them. And why they have actually missed all of them is that because this traditional QC practice that we have in software is not built, let's say, for a non-deterministic world, right? So what has been happening so far is that let's say whatever deterministic product that you're building, right? For example, let's say you're trying to build a login page for a net banking platform. Let's say it's an HDFC bank or a Kotak bank, right? Now, what is happening in the very first place is that the number of user actions that are going to happen on that interface is something like which is very limited, right? Because if you look at the nature of the product itself, you have kind of constrained it. It's not like, say, there's no free floating text window available on any of the net banking pages of, let's say, HDFC Bank or Kotak Bank. You have certain fields where user is expected to, let's say, enter something in a very specific format. For example, if you have to enter password has to be a combination of, let's say, letters and alphabets. Username has to be, let's say, a combination of a text string and let's say, some kind of numeric digits. And there is very less space. There's kind of very less freedom that you have even given to your audience to come and kind of enter different type of queries. And secondly, since you have limited the inputs also, and this is a very deterministic system, and hence you are able to kind of also control the outputs. Now, what I'm actually meaning to say by this example, let's try to understand it in detail with this specific example, let's say, in detail, right? So what could possibly happen, let's say, in a login flow scenario, is that user is placing a login request, right? Now, the first use case is that user enters enters like a correct login and password pair, and hence the login happens. So it's like a very happy scenario, and I think we can test it, let's say, in production n number of times, and it is not supposed to break, let's say, once it is tested. The second thing that could actually happen is that the user is basically entering a wrong login password pair, right? So this is so what would actually happen is that since this is a login screen, you will not allow the user to access the system. You will kind of block the access to that specific system and assume that at this point in time you have some kind of retries available. So when you are building this specific product, you said that, like, I'll allow a user to do, let's say, retries for 3 to 4 number of times, and once he has exhausted his retries, then only I'm basically going to block the action. So in the next step, what might so happen is that a user is basically selecting a wrong login ID password pair, right? And hence the login basically gets failed, and finally the account gets locked, right? Now, all of the scenarios which are expected to happen, you are able to kind of create a mental map of it because of two things. A, you have kind of constrained the input itself. And secondly, the system itself is very deterministic because you have instructed the system with your different if and else conditions that, like, if this happens, then this is the action that you have to take, right? But the entire thing actually changes when you comes to an non-deterministic world, which is basically powered by different LLMs, right? So let's take a very simple example, right? So it might so happen that LLM is able to answer your query, let's say, correctly certain number of times. But when you try to ask this query again and again, the LLM actually tends to hallucinate. A very simple example is that so this is something like which is proven again and again, let's say in different researches also, that if you ask the same question again and again to LLMs, it might so happen that out of 100 times, 99 times the response comes out to be true, but the 100th time the response is something like which goes off the roof. This could even happen. This could even happen for as simple as queries as that. What are the number of A's in banana, right? So it might so happen that the LLM is able to answer it correctly 99 of the time, 99 times out of 100, that like the number of A's in banana is actually 3. But on the 100th time, it basically starts sending the answer as 4. So hallucination is like a well-known problem in the AI world. So that is what is also basically making this entire thing very, very non-deterministic. The second thing that I actually wanted to talk about, right? That there is no single input output pair which you can actually establish. So for a single input also, you can actually have multiple output scenarios, and all of those output scenarios are correct, like same themselves, because like we are taking our software to, let's say, the next level, where rather than doing very, very simplistic deterministic tasks, now we are doing, let's say, a lot of tasks which are non-deterministic and involves creativity also, right? And creativity by the very nature cannot be controlled, right? You cannot define that like, okay, you have to create an artifact, and this artifact can only be created, let's say, within this boundary, because creation in itself is a term which does not have, let's say, very, very well defined boundaries. So I want you to basically take probably an year back. Imagine that like India was playing South Africa in a test match, and the test match was expected to happen in Guwahati. And Guwahati was basically a very, very specific kind of a geographical condition during that time of the year, when the sunset was actually happening earlier. And because of this early sunset kind of a situation, a decision was taken that like in this test match, we are going to first take tea followed by lunch session, which is otherwise not the case in any kind of a test matches which are happening across the world. Because first in the first session, when the first session ends, you kind of take a lunch and then followed by a tea after the end of the second session, right? Now, if you take the same article, let's say if you take the same article from ESPN Cricket Info and you put into any kind of an LLM and ask it to summarize, right? It can basically send you, let's say, multiple different outputs, let's say output 1 and output 2, right? And I do not even want to go into, let's say, what this output 1 and output 2 is, right? I wanted to take a step back and understand that, like, as a product manager, what would you think that, like, what is the right kind of a summarization, right? So if I just try and revise the article, right, it has probably 3 or 4 most important things. The first important thing is that like there's a test match which is happening in Guwahati, right? The second important fact is that Guwahati, by virtue of, let's say, multiple things, is falling in a situation where an early sunset is actually going to happen. And because of this early sunset happening, the test match will have a change in the schedule where tea will actually happen first and the lunch will actually happen later, right? So without looking at the output, you also have some kind of a rubric in your mind that, okay, what is the right kind of an outcome which is going to look like from an LLM output perspective. And now you start looking at the different outputs. So the first output is that the Guwahati test will have a tea before lunch due to early sunset. Okay, that looks correct because the system was able to tell that there's a test match which is happening in Guwahati, and there's an early sunset which is happening. And hence, because of that, the tea is going to happen, let's say, before lunch. Okay, so there's nothing wrong, let's say, with this specific output, right? The second thing, the second output, when you start kind of reading it, it also basically tells that there's a test match which is going to happen, let's say, in Guwahati. And Guwahati is going to encounter a special situation where you are expecting to have an earlier sunset. And because of this, you're basically letting have because of this, you are letting change in the schedule of the test match where tea will basically happen before lunch, right? Now, all of these two outputs, right, are looking correct because the kind of rubrics that you have defined, both of the outputs are actually kind of following that specific rubric. But again, going back and comparing it to the traditional software, what is happening is that for a given input, there is no definite output pair. There are, let's say, multiple output pairs, which is not even able to, which cannot be, let's say, predetermined, let's say, by a human being. Okay. Now, so whenever, let's say, you're trying to build and kind of an AI system and thinking about of this concept in general, you have to also be considerate of the fact that like what kind of AI system are you building, right? First of all, it might so happen that your AI system is not even able to, is not even designed to kind of do the required job. And the second thing is that it might be kind of designed to do the required job, but the way it is actually doing it, it is not very, very consistent, right? So whenever you're trying to build, let's say, any kind of an AI system, what you have to think about is the concept of capability versus consistency, right? Now let's try and understand that like what this concept of capability and consistency actually means. Okay. Now let's take a system where it is not capable enough. Let's take an AI system which is which is not even capable to kind of do the task that we are asking them to do, right? The task actually goes like following, right? That you have taken a sentiment detection model and you have plugged it into AI system, and then you're asking it to basically solve a very complex mathematical problem. Now, this sentiment detection model itself is not capable of, let's say, doing any kind of a complex mathematical problem. And hence, even if you try this particular kind of a system 7 times, 8 times, 10 times, you're bound to fail because your AI system is not even capable. I mean, leave aside the concept of consistency, because if it is not even capable, it cannot create the results consistency. The second thing that could actually happen is that you might end up creating a system which is capable but not consistent. So let's change the scenario like that you have an AI powered chatbot. Maybe let's say something which is very similar to the Rufus chatbot or the Alex chatbot that like we have thought about, that we have discussed about, let's say in the very starting of a slide. What is happening in this chatbot is that there are multiple customer queries coming, right? Now, when multiple customer queries are coming, your AI powered chatbot is designed in such a way that it is designed to kind of handle those customer queries, bring in the relevant context of from, let's say, your e-commerce website which is related to these queries, and then surface the right answers to the users, right? And because of the very nature of the LLMs or the kind of, let's say, system that you have designed, there's a probability that like sometimes you might get the right answer and sometimes you might actually get the wrong answers, right? So what this actually means is that it is not the case that your AI system is not even capable of kind of handling this kind of setup. It is capable, but because of the very nature of the AI product, it is something like which is not very consistent. Now, let's say if you have to define the concept of capability and consistency in the form of a metric. Let's say if somebody tells you that like, hey, help me understand in form of a metric view that like what kind of AI system are we building, and how do I understand that like it's a capability gap or it's a consistency gap? What is the right metric that I can choose, right? So the two metrics that you can choose to define whether your AI system is like say either capable or not capable or consistent or not considered is something called as pass at K and something called as basically reliable at K, right? Now, what this metrics mean? This metric means is something. What this metric mean is something like which is very simple. So I'm going to take, let's say, the same example of your let's say sentiment detection model, right? Now, what pass at K actually means is that if we're going to take an K number of tries, right, and out of the K tries, what is the probability that your entire system was able to generate the right answer at least once, right? Now, in this case, what is going to happen is that like since the model itself is not capable, so you're not even expecting the right answer at any point in time. Hence, the value of pass at K is actually going to be 0, which denotes that like your system itself is not capable. Now, if system itself is not capable, then there is no point in measuring the consistency of it, like which you basically measure using reliable at K, right? Now, let's understand that like what does reliable at K actually means, right? So what reliable at K as a metric means is that if you're going to have, let's say, K number of tries, and if you're going to try your system, let's say K number of times, what are the number of times that it actually fetches the correct output, right? So to kind of put things into perspective, let's go back to the same, let's go back to the second example where we talked about a system which is capable but not consistent, right? Now in this system, what might so happen is that like you have an AI powered chatbot, and we discussed that like the system is something like which is capable. Sometimes it handles the query, sometimes it does not handle the query. So if I put this, let's say in the lens of the pass at K metrics, let's say if I'm doing 5 number of tries and I'm trying to basically do a simple query of the customer, and let's say the query of the customer is that give me all of the mobile phones which are under 30,000 budget, right? And the mobile and the answer which is actually coming to us, let's say the system is able to give us the answer, let's say two times correctly. So the pass at K metric still becomes, let's say 1, because at least because the model is actually able to kind of give us the correct answer, at least once. But in terms of, let's say, reliable at K, what is going to happen is that like out of the 5 turns, only 2 times the answers came correctly. And hence the reliable at K matrix becomes 2 by 5, which is nothing but 0.4. So what we can say, let's say as a product manager, is that like if you have to establish the gap between capability and consistency, the difference between the pass at K metrics and the reliable at K metrics is something which defines the gap between capability and consistency. And this gap can even be 0. Let's say if you go to a very deterministic kind of a system, if I go to, let's say, the same net banking page example again, right, where both pass at K and the reliable at K values are going to be similarly same because it's a very deterministic system and you have programmed it in such a way that for every correct input pair, it is going to give you the correct right output pair. So in this case, the system, a very deterministic system becomes both capable and consistent. Now, I hope that like we are clear to a certain extent about that, like what is so different in some kind of an AI system that we have, right? What is the gap between capability and consistency, and how it is very different than a non-deterministic system that like we have, right? Now let's also spend probably a minute or a couple of minutes to understand that like how all of us would have been trying to understand that, how do I create this eval, etc. So I'm very sure that like all of the audience that is sitting here would have tried to create something, let's say on their own using the different AI tools like which are available. What we do typically is that like we kind of create an AI application. We try and basically input certain questions of ours or certain test cases of ours. We kind of observe the output, which we can basically call as vibe checks. And if we feel that, okay, yeah, this is working 80%, but 20%, like this is the gap, what we try to do is that like we try to make those observations, make certain iterations to our, let's say AI model, which to our AI system, which could be, let's say either an iteration in terms of the prompt in the very, very basic prompt that you are trying to write for this specific model. Then we try to kind of retest it again. So this is like a loop which we probably try to run 3 times, 4 times, 5 times, 6 times, or depending upon use case, let's say n number of times. So this is a process that like all of us could be following, but the above approach is something like which is a very, very fundamental approach of doing the testing. But this approach is something like which is not scalable. What we are saying is that it is not the case that like this approach is something which you should completely, let's say, throw out of the window. It's not the case. It definitely helps you understand the broader fine footprints of your AI system, that like what is working well, what is not working well. But it's not something like which is a very scalable thing, and you can actually plug it into let's say your production ready system. Right. So hence, what we need is that like there's a need of the hour that like we need a proper evaluation system to measure the consistency of our AI systems, right? Maybe using this specific check, like you can at least understand that like your model is kind of capable also or not, because in all of the iterations, if the model is not able to give you any right answer, let's say if I go back to the example where we were using like a sentiment detection model to basically solve a complex mathematical problem, no matter how many iterations you do, no matter how many modifications you do, right, you're not never going to kind of get the right answer. So hence, as part of this process, you might so understand, okay, my system itself is not capable, right? So the question of consistency is something like which is very, very far away. First, I should make it capable. But after doing this exercise, if you find certain green shoots that yes, your model is behaving in a way that you expect it to behave, but there's an element of consistency, this is where you basically start thinking about evals. Right. Now let's probably spend a time to understand that like what this eval actually is, right? So an eval is nothing but it's a short form for evaluation, right? And it's a structured text to check the performance of an AI system. It helps, let's say anybody like who's a system owner, be it the engineer or be it the product manager, measure the quality, reliability, and correctness across different scenarios. Okay. Now we have understood that like how AI system is very non-deterministic. Why do we need, let's say, evals? Now let's also spend some time to understand the type of evals and like when should you use them. Now this is a very important concept because I think many times you would be seeing this common perception going, let's say, around your workplace, around, let's say, different social media platforms as well, where people are saying that, okay, if you have to write evals, use an eval and start, let's say, and make him basically act as a judge for you, right? Which is definitely not the right process. But if you know that like what is the different kind of problem statements you're going to encounter and how each kind of an eval is suited to handle the problem statement, right, you'll become more potent in taking the call that like what kind of eval you have to use. Because I think all of us know that LLMs comes at a cost. There's a huge amount of token cost which is associated, and everybody, let's say as a product owner, has to be very judicious in how do we want to spend this, let's say, cost while judging the outcomes of our AI system. So the first kind of a eval is something which is called as a code-based eval, right? So what does a code-based eval actually do, and how do you use it? Is that so when your evaluation criterion is, let's say, very, very deterministic. Now you might question that like, hey, we have just spoken, let's say, about 10 minutes back that my AI system is completely non-deterministic. So why we are bringing in the question that like, okay, if there's anything deterministic to check, you kind of bring the AI, you kind of bring the code-based model, right? So yes, the broader concept is correct that the response of the entire AI system is something like which is very, very non-deterministic. But the portions of it, so let's say if I look at the entire response, a part of the response or a part of the entire AI system can be deterministic as well. Let's say your AI system is supposed to, I'm again going back to the shopping bot wala example, where when a customer kind of launches a input query, the system completely processes it, and the output of the system needs to be shown to the user, right? Now there's a prerequisite between how the systems are designed, that like when the output is coming from your AI system and when it's supposed to be shown, let's say on the customer on the app, the entire handshake should happen on the basis of an API response, which should follow just, let's say, JSON and structure, right? Now in this entire construct of your AI model, this specific part, that the handling between the output of the AI system and the customer application has to be, let's say, in a JSON format, right? Now this small part of your AI system actually becomes deterministic. Okay. Now, in all of such cases, like you can actually use a code-based eval, because these problems are something like which are solved well in advance. It is not solved now. It has been solved, let's say, for years. And there is no point in actually building a complex system where you're trying to kind of judge something, let's say, on a very, very smaller or some things when you're trying to kind of judge something which is very, very trivial, right? Another example could be the format structure also, right? So let's say, imagine that like you are building a nice application. You are trying to, let's say, do a lot of explanations to the user that like, okay, maybe you should, or maybe let's say you're trying to, let's say, create again like the summarization app that we have talked about, right? Let's say you're trying to create, let's say, even further shortened version of in shorts, saying that I'll probably provide, let's say, a 3 sentence kind of a summary to my users. And the moment it kind of expands beyond 3 sentence, it is something like which is of no use to me, because the way I have defined my mobile interface, I cannot, let's say, show more than 100 characters to a user, right? Now, in this kind of an AI system also, let's say when the input goes to the model, the output comes, you are kind of creating a condition that like, hey, the output should be contained within 100 characters. And you should have given this as an instruction within your prompt also. But as we have discussed that like many times LLMs tend to kind of hallucinate, and hence it might so happen that like at times, probably let's say 10% or 12% of the times, it is throwing us a response which is more than 100 characters, right? Now for this kind of a problem also, you can use a code-based eval. What you can do is that like you can simply read the character length, and if it is not meeting the criterion, you kind of go back, retry and generate it again. And you can actually have it as a loop with a maximum number of tries, that like, okay, if I've tried, let's say 4 or 5 number of times, and if the problem is coming again and again, maybe I will kind of drop this particular piece of article from summarization itself, because of, let's say, whatever issue. The article itself is so big enough that it cannot be, let's say, contained within 3 sentences in a very, very meaningful manner. Okay. Now, the second concept that I want to talk about is something called as the off-the-shelf ML models, right? Now, what actually off-the-shelf ML model means is that it's not the case that the entire world of AI and LLMs is something like which is
Apur,
very, very, yeah.
Apur, like there's a question. Like basically code-based can be used when a response meet an expected assertion.
Sorry, so the response meter?
Actually, can you
Yeah.
let's say voice it out?
Yes. So I just need one clarity. Basically, we are saying code based. Let's say we have calendars as an example, right?
Yeah.
Now that we know that response has to give either a meeting time, etc. Right? It's quantifiable.
Yeah.
So
Yeah.
this is where one can use code based, right? Like
Yes, yes, yes.
yes. Got it. Okay, makes sense.
Yeah.
And
Also,
whenever it is subjective, let's say. Sorry, and whenever it's a subjective, let's say summary of a particular meeting, etc., that is where wouldn't come in code base, because that's something not quantifiable, could be quantifiable in terms of, let's say, lines or something, right?
Yeah, you're absolutely correct. I think in summarization, the scope where you want to get it contained, let's say within a specific character count or within a specific sentence count, is something that you can handle with code-based evals. But the moment, let's say, you are trying to do evaluation, let's say, which is with respect to the tone of the entire thing or the correctness of the entire thing, this is where this code-based evals will not work.
Got it. Makes sense. Thank you.
yeah, about Nitin has a request. Like, can you be a little slow, please? So, like,
Sure.
slightly slower, but
Sure. Thank you, Nitin, for the feedback. I'll try to be slightly slower in my pace, like when I'm delivering. Yeah. Okay, so code-based model is something, evals is something that like we have discussed. Now let's go back to the another model, which is basically called as off-the-shelf ML models, right? Now what I was just saying is that the entire world of, let's say, AI and LLMs is something like which is not very, very new, right? So there have been a lot of advancements, a lot of work which is going in the traditional ML world, and this goes back to, let's say, maybe decades or so, right? So there are certain problems, let's say, which are very, very solved by this ecosystem, which do not even, let's say, which do not even require the need of LLMs, right? And these are the problems which are still very non-deterministic in nature, but are let's say not so non-ambiguous, but are let's say not so ambiguous, and they are let's say very well solved, and have been solved let's say by different people, let's say using some kind of a generic or external data, right? So now what I actually mean by this is that, let's say if you have to, I'm just taking the example I think which somebody was quoting here. Sorry, I'm not able to see the name so screen, so I'm not able to kind of call out the names that like who asked this question. But let's say in the same calendar example itself, right? If I have to kind of create the summarization of a meeting, and if I want to check that like in the meeting, I want to ensure that the entire tone of summary is something like which is very polite and very professional, right? Now this kind of a model, for this kind of a let's say problem statement, I can use any off the shelf ML models which is available, let's say onto the onto the real world. Most of these models you will be able to let's say find on Hugging Face. And the demo that like we are going to do at the end of the session, we are also going to tell you that like how are you going to let's say plug in an off the shelf model and do these kind of an evaluation. Some other things which comes to our mind that where you can use this kind of an event system is that, let's say sentiment is something that like we have discussed, but if you have to also identify certain kind of an PII, what does an PII? PII is basically nothing but personal identification, personal identifiable information, right? So what it says is that, let's say you're creating a model and the summary, you do not want any kind of a customer PII to come out. Let's say I'm kind of doing a query, right? Or let's say you are building any kind of an AI system where you want to kind of keep things, let's say very anonymous. So you want to ensure that like anything which helps you kind of detect that like who was the responder of this specific, let's say, question, you do not want to come out. Maybe think about the different kind of employee surveys that you might be having in that organization, which are supposed to be anonymous, right? And if you're creating, let's say, an AI system for that, and what might happen is that like you're getting an output where you're getting, let's say, a lot of PII information and you want to check it if the output contains any PII. You can use, let's say, an off-the-shelf eval model to kind of understand that like if AI system is behaving correctly also or not. Now, the third thing that like we can move is to something called as LLMs judge, right? Now, I think by now you would have guessed it that like when do we even use LLM as a judge? We use LLM as judge when the evaluation criterion is something which is very non-deterministic and it is also very non-generic, right? By non-generic is like not the problem statements like how do I identify that? What is the sentiment in this conversation? Like is there a PI in this conversation? But if the issue becomes, let's say, very complex, that you have created, let's say, this Alex as the chatbot or Rufus as the chatbot, and you are having a very long range of conversation between the customer and the chatbot, and the customer is becoming frustrated because AI is not able to answer it correctly. And hence the customer expects that like at this point in time, let's say the AI kind of shifts this conversation to a human, right? So how do you kind of assess the scenarios which has this handoff issues is somewhere this LLMs kind of comes and use. It might also happen that like you also want to keep a check, let's say, on out of the scope answer. Let's say there's a wealth tech platform which is available, which is kind of working in India. And as part of the regulatory guide rails, it might so happen that like these platforms are not supposed to give any kind of investment advice to its consumers. So let's say I as a consumer goes and type that like, hey, I have a portfolio of approximately 10 lakh rupees. I have additional 1 lakh rupees in my hand. Can you please give me the recommendations of stocks or mutual funds? Where should I actually go and invest it? Now, these are the issues, let's say, which are very non-deterministic, because since you have given a chat box as an interface, there is nothing which is stopping me in asking this question to the AI system. But as your guardrail, you do not want the AI system to answer, because typically what happens with any kind of an AI system is that like, I mean, they tend to be very helpful because they have the world knowledge. Even if they do not know the things completely, they generally try to be, let's say, very handful. So to understand if these kind of, let's say, out of the scope answer related issues is happening, let's say, within your ecosystem also or not, this problem is also, let's say, something which is very non-deterministic and non-generic, and hence you use LLM as a judge to kind of create this eval for you. Now, one thing which is very important, I think, which I was discussing, like said at the very start of the slide, is that when you're trying to take a decision as a product manager, that like what kind of evals should I use, you should have a very simple guiding principle that do not use a costly and complex solution for a very simple task, right? And in terms of cost, you can typically have this kind of a framework, let's say in your mind, although I don't think there's a large difference between the cost of, let's say, a code-based eval and off-the-shelf models, but this is a simple kind of a metrics that you can keep in your mind that like if the task is very, very simple, very, very deterministic, I'll not try and solve, let's say, using any off-the-shelf model or LLM. I'll simply use, let's say, a code-based evals. If the complexity increases further and it is a generic problem, I'll use, let's say, an off-the-shelf model for my eval system. And if the complexity of the next degree and it's very non-deterministic, very non-generic, then I'll actually use LLMs as evals. Okay. This is, let's say, also a very, very simple framework that you can keep in mind when you're trying to see that what kind of eval you should build, right? And whenever you're thinking about it, you should basically try to strike a balance between the cost and complexity. So what you see, let's say on your screen is, let's say, a typical 2x2 metric, where in the x-axis, you basically get to see the cost and effort that you have to put to create this eval, which definitely goes from, let's say, a low to a high state. And on y-axis, you're basically seeing the depth of the evaluation, that like whether it was simple or whether the problem is completely, let's say, complex, right? So you can divide this entire chart into 4 different quadrants. And the first quadrant, let's say, if the depth of evaluation itself is, let's say, very, very simple, and it does not require, let's say, too much of an effort to even figure out that like what is the problem, you should use, let's say, a code-based evals because it is something which is also very cost efficient. Then comes the second case where your depth of evaluation becomes slightly more complex, but the effort required to do so is something like which is not so complex because somebody has solved already this problem. This problem is out there in the world, let's say, for years. And using external data, somebody has solved this problem to a great extent. You start using something called as the ML-based evals, using any kind of off-the-shelf model which is available as per your use case. Now comes the third part where the effort to kind of solve that problem itself is very, very high. And the problem in itself is something like which is very complex, which you cannot solve, let's say, either using a code-based evals or an LLM-based evals. And this is, let's say, where you use basically LLM as a judge. Now, the fourth quadrant is, like, say, probably a place where many people, let's say, in their life tends to make a mistake that like where the cost and effort is let's say something like which is very, very you're for a problem which is of very low complexity, right? You're trying to use, let's say, a solution like which is very, very costly, which involves, let's say, a lot of effort. So this is like a strict no. So this is the quadrant that you should always avoid while selecting that, like, how do I kind of create my eval system. Okay. Now, so far we have talked about that, like, say, what are the different type of evals, what is a code-based eval, what is an off-the-shelf model, what is an eval where I can leverage, let's say, an off-the-shelf model. And we've also talked about something called as LLMS judge. Going forward, let's say whatever discussion that we are going to have in the next subsequent slides, we are going to deep dive further, let's say, on LLMS judge, and whatever concepts that we are going to cover, we are going to cover that in with respect to LLMS judge, right? Now, whenever, let's say, we are talking about a judge, right? How will you, let's say, judge a person? For example, if I'm sitting in an interview and I'm supposed to interview a candidate, right? As a judge, I should know that the questions that the interviewer that the candidate is getting asked, what is the right answer? Because if I do not even know the right answer, or at least how does a right answer look like, there is no way I can actually judge that answer because I do not even have a capability that, like, how do I even go and judge it, right? Now, this is the case. In the next 2 slides, we're going to talk about that, like, say, how do we tell LLMs that what is the right answer? And this is, let's say, where the reference framework kind of comes into play, that how will that to what reference of an answer an LLM as a judge is going to compare the response of an AI system and then going to do an evaluation. So from a reference perspective also, there are 2 kind of evals. We basically call them as reference-free evals and reference-based evals. First, we are going to discuss about something called as reference-based evals. Now, what is a reference-based evals? What this actually means is that, say, in kind of a reference-based evals, you already know that, like, what is the right answer or what is a good answer looking like. So some of the examples here could be, let's say you're trying to build an AI system where if somebody types in that, like, hey, tell me that what are the number of days in the last month where my revenue of the platform, let's say, was more than $1 million. Right. So the answer to this problem is something, let's say, which is very, very specific. Everybody knows that, okay, there were, let's say, probably 13 days where the revenue of the platform crossed $1 million. And hence the answer itself is something like which is available to you in some shape and form, right? Now, this is like a use case for referenced based evals where you will try and understand, where the LLM will try and understand that, like, okay, did the response came out to be, let's say, 13 days also or not, right? The second kind of an example is something called as a data extraction. When you are basically extracting some data points, let's say from an annual report, let's say you're looking at the annual report of Blinkit or Eternal, and you're trying to understand that, like, okay, in the quarter two of, let's say, financial year 2025, what was the revenue, what were the growth numbers, what were the number of dark stores, etc. So all of this information is something like which is already available, and this becomes like a reference for the LLM to understand that whether the answer came out to be correct also or not, right? Now one might answer, or let's say one might have an argument that, like, okay, there are multiple ways of, let's say, writing an SQL query. Now if there are multiple ways, how does an LLM know that, like, what is the correct way? So the confusion comes here is that we are not focusing upon that, like, how you're writing the query. The reference is the final answer, that, like, if I'm able to answer correctly that the number of days on which the revenue was more than 1 million was 13, that becomes the reference point for me, not the different ways of kind of writing the queries and arriving at that particular 13 days number. The second part here is basically reference-free evals. Now, what this kind of a world means is that the output is, let's say, very open-ended, and it is very hard to fixate like a model answer for a question. For example, I simply go and basically tell ChatGPT that, like, hey, write a blog about evals for me, right? Now it is very difficult to understand that, like, what is the right answer, and hence we have to rely upon the world's knowledge of the LLM to understand whether our AI system is even doing a great job also. Now a quick kind of a question. So I think most of the evals that you're going to face in your life, right, are neither going to be, let's say, on the one side, nor they're going to be on the other extreme. There are going to be a lot of evals which are more kind of hybrid in nature, where there's something called as a reference-based thing. A part of it is, let's say, reference based, versus, let's say, a part of it is reference free, right? So just to help you visualize this concept, let's imagine that, like, you have a contract, right? And the contract, let's say it's a legal contract between two entities, and this legal contract, let's say, contains 50 different dates regarding that, like, when the task A should be completed, like, if it does not get completed, what is the penalty, etc., 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 right? Now in this case, when you're, let's say, trying to create an eval, it is both reference based and reference free, because if you ask a question to your AI system that, like, hey, tell me what is the most important date, like, let's say, in this entire contract document, right? So none of the dates that the model is going to predict should be outside the 50 dates that the contract actually contains. And what date becomes, let's say, most important is something like which is predicted, which is kind of determined by the LLM's world knowledge, because there is no way to define that, like, what is the most correct date, like, say, in the entire contract. So these kind of systems, or these kind of, let's say, setups, leads to a state where the entire eval becomes, let's say, a hybrid of reference free and reference based evals. Now we have talked about that what are evals, like, what are reference B, what is, let's say, reference free evals. Now if, let's say, you have built an AI system, and now you're trying to understand that, okay, my AI system is there, and how do I even start, let's say, building a response, or say building an eval around it, right? So the first very simple step is something which is called as trace analysis, right? Now before even going into, let's say, what is a trace analysis actually means, let's try and understand in a very simplistic terms that, like, what actually trace is, right? So trace is nothing but, you can assume, like, in a very simple way, that it is nothing but the log of your entire system, which gives you the entire understanding about how did your system behave when a user inputted a query, how did the query gets processed within the system, and, like, how was the output fetched. So it's an entire log of all of the actions which your system is trying to do, and then trying to create an output for you, right? So and what might so happen is that, like, in this entire trace, you might actually have multiple spans. So the spans are nothing but, you can simply think that, like, let's say these are different steps that might be required for an LLM to understand that, okay, let's say, how the final output is generated. Okay. Now the next question that might come is that, like, okay, where do I see these traces, right? So again, the example or say the answer varies depending upon situation. Let's say if you're not building a very complex kind of a system where let's say just like a simple single step task. Let's say you're trying to ask that like, okay, there's some kind of a outfit recommendation coming. Is it, like, say, even correct from a fashion sense perspective, etc., or not? Right? You can simply use the input queries, and on the other side, you can actually put like a dump of it, that like how does the output look like, and try and understand that, okay, for an input, how does an output look like? But in certain cases, the entire thing actually becomes very, very complex. For example, when you have to talk about a rack kind of an architecture, or if you have to talk about an agentic kind of an architecture, the stress analysis does not become, let's say, so and so simple. And hence there are a lot of third-party applications which are available right now, which help you kind of build this observability, let's say, around your AI systems. Some of the famous names which are coming to mind is, let's say, your likes of Brain Trust, Evidently, Arise, etc. Okay, so now we have understood that like what a trace is actually. Let's also try to understand that like what all does it contain, right? So let's say in the same example of our shopping bot, the user question which comes to us is that like, hey, what is the return policy for electronics, right? Now, in this specific case, what might so happen, and again, like this is a sample scenario where first somebody will try and understand that, like, okay, what is actually the user asking to me, right? Like, what is the kind of language that he's using? If there's any kind of fillers that the user has used, like, he'll probably try and remove it. In the second thing, like, say, what will happen is that, let's say, in these kind of systems, typically when you have to fetch the knowledge from when the knowledge is required, not from the outer world, but let's say from a very, very guarded world, right? You kind of use a rack kind of a system. So when I say that, like, what is the return policy of electronics? What LLM might know is that, like, okay, there are 100 different e-commerce platforms available in the world, and somebody probably allows 10 days, somebody allows 20 days. So if it simply directly relies upon LLMs, what they simply say is that, like, okay, I'll just take the average of 10 and 20, and hence the return policy becomes 15 days, right? But this is not the case, because this policy can change depending upon the e-commerce platform that you are on. So let's say on Amazon it could be different, on Flipkart it could be different, and let's say on any other platform it could be different, right? So in this space, what you will do is that, like, first you'll try to convert this entire question into some kind of an embedding. What you will do is that, like, let's say embedding is nothing but the representation of, let's say, this entire sentence or this entire question into some kind of, let's say, numbers. And then you would already have, let's say, a lot of your policy documents available within the ecosystem. Let's say you are creating this entire shopping bot for an e-commerce platform called as X. So you would already have this numerical representation created for different policies also. What you will do is that, like, you'll try to basically do a similarity match, that for this kind of a query, what is the right document, like, which is coming, or what is the right set of documents, let's say, which are coming. You're going to basically fetch some 4 or 5 different documents also. And then what you're going to do is that, like, you're going to create, let's say, a complete answer of what is the return policy, let's say, for the electronics. Now, this trace itself looks differently, let's say, in different use cases. For example, depending upon the architecture, as I was just hinting, the trace itself could either be, let's say, of very low complexity. It could be of, let's say, slightly higher complexity, medium complexity, or it can be, let's say, of the highest complexity, right? So let's take an example of something, let's say, which is of very, very low complexity, right? So let's say in the scenario A, user simply submits, let's say, a 500-page document and says that, like, hey, translate this from, let's say, English to French, right? So it's like a simple 2-step thing that the entire request was, let's say, triggered by a user. Let's say we have built some kind of input validation that we are not translating something like which is a prohibited, or let's say which is not like a content as per our let's say guardrails. And the last thing, like, say, what we end up doing is that, like, we simply kind of do an LLM call and understand that, like, like, say, what is the output coming out to be, right? Now, one thing that you can actually notice here is that, like, say, apart from the output that you will be able to read, there is a lot of other metadata which is also available as part of the trace, right? So you can see that, like, if a request is coming to you, the overall time which is taken by your system to process this query is about approximately 800 milliseconds, out of which, if it's a 2-step process, 50 milliseconds was, let's say, taken by this particular step, and 750 milliseconds was taken by, let's say, this specific step, right? So tomorrow, if you have to even go to a state like where you're not so, let's say, worried about the output of the system, but you are worried about the speed of the system, this trace analysis also helps there, because you are able to now understand exactly that if it's a multi-step process, which step is consuming how much of the time, and where does the opportunity exist for the optimization. The second question, apart from let's say evals, which also comes to your mind is basically the cost of your AI system, because you have to also be rational in terms of that, like, okay, what is the cost? What is the token which is getting consumed in each and every step, right? So this also, you can also kind of go and log in that, like, okay, what is the kind of metadata which is available? Or sorry, like you can also kind of go and log in different metadata, that what was the kind of model used, how many tokens did it consume, so that like tomorrow if it comes to rationalization, you can also look at this particular kind of metadata and optimize that, like how do I kind of optimize my response time, how do I, let's say, optimize my cost for the cost for the AI system also. Now let's go to a scenario which is having a slightly medium level of complexity, right? It is something which is a typical RAG kind of an ecosystem. And again, RAG is nothing but where probably more than the overall world's knowledge, you want to kind of generate an answer within a fixed set of, let's say, relevance, or within, let's say, a fixed set of knowledge documents. What might so happen is that, like, say, one thing that you start seeing is that first overall response time is actually increasing, and the number of steps that are required to kind of generate this answer also increases. So let's say you will first create this question into an embedding that, like, how do I reset my router? How can I represent this like into some kind of an embedding space? And then you'll try to basically find that, like, for this kind of a query, what is the right kind of a manual document? And then you basically combine, you create a prompt saying that, like, okay, this is the question and this is the right set of documents that LLM should use to answer. You send this to LLM, and LLM finally generates that, like, hey, what is the right answer for the specific question? So what you are seeing here is that in terms of complexity, it is slightly becoming more and more complex, because now there are, let's say, multiple steps that you are getting to see. Now comes the third scenario, let's say, where the trace actually becomes really more complex. So let's say you are trying to create a multi-agent system, or let's say an agentic system, where simply a user can go and ask that, like, hey, book me a flight to Bombay, right, from Delhi, and find a hotel which is under 10,000 rupees, and the hotel should be situated, let's say, near Bandra. So what you're seeing across the different traces is that, like, the first trace was just having approximately, say, two different child spans. Then, like, it has, let's say, four different steps that the entire thing is taking. And in this specific case, the entire AI system is taking approximately five different steps. Okay. Now, the first step is that, like, okay, what is the user even asking? How do I understand it? So the user is basically asking for a flight search and a hotel booking, and hotel search and booking kind of a scenario. In the second thing, you basically trigger an external API call to an airline aggregator, gets all of the relevant flights. In the next step, you also basically call an aggregator to the hotel booking site, get all of the relevant hotels, which are as per the description of the user, which is, let's say, under 10,000 rupees under Bandra, right? And then is also a step where you basically take two of these responses and combine them together, because it might not so happen that your flight is reaching, let's say, at 10 a.m. in the morning on 20th of April, and you're booking a hotel, like, which is on 12 of the afternoon on 21st of April, right? So you basically get both of both of these things together and try and reason them, like, okay, like, do they look in tandem? Do they not look in tandem? And once you've done all of the checks, the final response is basically sent back to the user, where he kind of where a consolidated itinerary or different options of itineraries are actually shown to him or her. Now, so these are the different kind of traces that, like, you might actually encounter in your system, depending upon the kind of architecture your AI system has. But to do a trace analysis, you can simply follow, let's say, this 5-step process. And if you try to basically find this 5-step process, you'll have a very good control of that. What is the kind of response that your AI system is going to give to you, right? So the first thing is, there is no magic bullet here. You have to read the traces, right? So let's say if you are the product owner and you understand your domain really well, it has to be either you or another subject matter expert that you believe, like, who is able to understand that, like, what is happening behind the scenes. So first you have to read the traces and understand that, like, what are the kind of questions which are coming and what is the kind of response that our AI system is doing. Usually it has to be, let's say, if you are able to do, let's say, with a single SME, it is better, because multiple people have multiple judgments, and then hence there could be, let's say, a conflict which could be arising in their judgment itself. Then you classify these outputs. More on this later. We will understand that, like, how good this output was from our AI system. Was it good enough? Was it not good enough? And if it was not good enough, how do I describe to an LLM that, like, what was missing into that? And once I have read, let's say, multiple traces, and let's say I have told the LLM system that like why it was good, why it was not good? How do I understand that like what was the broad ranges of issues which my AI system is facing, which we are basically going to do with a step called as axial cloning, which we are going to do with a step called as cluster collection, cluster creation using axial coding. And finally, when you're reading the traces, like nobody can read, let's say 200 or let's say 1,000 of traces. How do you understand that like, okay, I have read enough. I definitely cannot read all of the traces. And there's no further need for me to read traces anymore, and I can actually stop reading traces. Now, let's deep dive into each and yeah.
Yeah. So any question till now? Anyone can. Yeah.
I have one question.
Yeah.
So basically, I'm trying to stitch the story, right? What I understand is traces help you analyze, like it can help you analyze each of the steps. Let's say if it's a RAG, then there's retrieval, there is chunking and stuff, right?
Yeah.
But
Yeah.
For trace analysis, we can use external tools, or like how does that work? Like how do I go about creating these category, and then
Yeah.
so what I understand, it's like logs, but I'm not able to stitch that story. That how would that work basically?
Yeah. Maybe just allow us 10 minutes. So we are also going to create a show, let's say a sample example of how do you do it. Again, let's say there could be multiple ways of doing it, but we have a setup where we'll try and show you certain example outputs which are coming from a model. How do you open code it? How do you cluster it? And like say, how do you kind of understand it, like how many traces you have to read? Just hold on for 10 more minutes.
Got it.
Any other question? Anyone? Okay. Yeah, let's move on.
Yeah. So the first thing is that okay, I'm getting to see certain outputs. Now, how do I classify them, right? So as a PM, or let's say as somebody, let's say who kind of typically wants everything to be completely clean. The orientation would be that, okay, I'm receiving certain response from an LLM. I'll try to rate them, let's say on a scale of 1 to 5, where 5 being the best, 1 being the one, let's say being poor, right? Now, I think this is like a starting thought which many of us, let's say, would have when we are trying to kind of do a trace analysis. But I think this is something that like we should completely avoid, because when you're going to read approximately, let's say 100 or 150 odd traces, it is very difficult to become very objective in kind of assigning a score using the Likert scale. It might so happen that like for an output which is of near equal quality, sometimes you're assigning it a 3, and sometimes you're assigning it a 4, and sometimes let's say you're assigning it a 5, right? So the entire objectivity from, let's say, how you are kind of classifying this output goes out of the toss. And hence you should use like a simple binary classification that like, hey, whether it was a good response or whether it was not a good response. You should not try and basically middle between that, okay, I'll follow a rating between 1 to 5 or 1 to 3 or 1 to 10. That is like a clear no-no. Right? Now in the next step, what you're going to do is that like you're going to open code, let's say your responses, that like, why do you believe that this specific thing was either, let's say a good kind of uh, a response or no. And you can be, let's say, you can use as free flow text as possible. So again, like we're going to look it into an example. Let's probably go and jump into that example itself. Okay, you guys are able to see my screen?
Yeah, we are able to.
Yeah. Now, in this specific case, what we have done is that like we have simply taken the responses which could be coming from a, let's say, any kind of a wealth tech data platform. So what you have done is that you have created like a chatbot, and users can go and basically ask their queries. Now, again, like we do not, what we have done is that like we have taken the input, which is the user question, and the output scenarios, and we have just pasted them in column A. So what you get to see is that like what is the user asking, and then like say you also get to understand like what is the AI answering, and all of the scenarios that like we have taken here, like what the fail kind of a scenarios, that like all of the scenarios, as our SME says, is something like which is not correct and we should not let them process it. And what you see in basically column C is that like say how are we kind of even letting somebody know that like why this was a good output or why this was not a good output, right? So let's go through a few examples and understand that like where are the issues, what are the issues that you can encounter, and how do you kind of encode them. Okay. Now the first user interaction says that like, hey, I want to sell all my shares in Reliance Industries at the current market price immediately. AI, as usual, let's say, becomes very, very helpful. It says that like, okay, I understand your sell order for let's say for 100 share of Reliance Industries has been placed. The current market price is, let's say, 2,500. Okay. Now, this kind of an interaction, ideally, like a PM would not want to have in their system, because AI is kind of becoming over helpful and jumping the gun and taking a very important financial decision for the user without even confirming it twice, right? So we are basically calling it as fail. And simply, like as a PM or as an SME, you can simply say that like the AI did not even take any kind of a confirmation of quantity and price, and directly went ahead and kind of sold the shares. Okay. So imagine, just focus here that like I'm not following any kind of a template here. Like we're simply writing like in a very simple English language that we're using day in, day out. That like, hey, it did not do the steps, and hence like I'm basically marking it as a field. The second example where it comes is that like the user says that like, hey, my KYC documents have been pending for verification for 10 days. I'm really frustrated and I need to talk to the compliance officer right now. What AI typically does is that like it tries to again being over helpful, say that like, I apologize for the delay. Please upload a clear photo for your PAN card again and I'll prioritize your verification request. Now, if the request is, let's say, already pending, okay, and it's already pending for approximately 10 days, nobody would want to wait, let's say, for another 1 day, because what they are expecting is that like again this, and probably AI would have asked them to do this step already 10 number of times before this current instance. And hence, as a PM or as an SME, you will actually fail this scenario and saying that like, okay, this is a point where AI was trying to be over helpful, and rather because it was not able to handle that issue for himself, by himself or herself, he should have, let's say, handed over to a human in the loop. Okay. Let's take one more example, that can I use money in my mutual fund portfolio as a collateral for a home loan? AI says that let's absolutely, most of our partners accept mutual fund units as collateral. We can start the process for you now, right? It simply says that like it is starting a process which is as complex as, let's say, loan dispersal without any kind of a due diligence, etc. And hence this is also something like which is a fail scenario from an AI perspective, right? Now, it could also happen that simply somebody says that like, hey, what is the best strategy to, let's say, in the March month, right? There's a lot of kind of variation. There's a lot of kind of ups and downs going in the market, and somebody asked that like, okay, it's a very volatile market. What is the best strategy to maximize my returns? And the AI goes ahead and says that like the best strategy is to book profits in your large cap funds and immediately shift the entire amount into, let's say, some kind of an XYZ small cap fund, right? Again, let's say it's a very bad thing to do, because AI, or let's say this platform, is not supposed to kind of go overboard and advise something, because they are not and they are not an investment advisors. They are simply, let's say, investment platform, let's say, on their own, right? So these are certain examples, and these are the only examples that you're going to, let's say, see in your real AI world also, right? So what you simply do is that you just read through these examples and you simply describe in your very own natural language, that you go ahead and basically tell that why it did not kind of make a very good response. Okay. It could even make some kind of a factual mistake, saying that like, okay, somebody was asking that like, what is the tax implication? It says that like your STCG is 15%, but it's not correct, because its STG current prevailing rates are actually 20%. Any doubts about this entire open coding thing? And this open coding, why we are calling it open coding is because it's a relatively known term, let's say, across industry, and hence we are calling this commentary as open coding. Go ahead.
Yeah, sorry, I'm not able to raise hands, so that's I'm directly speaking, but
That's okay.
Yeah. So the Excel sheet that you showed, right? So
Yeah.
the assumption is that okay, we have set a criteria, and let's say the AI is not meeting. Let's say for the human handoff, right? We have asked
Yeah.
it that you're supposed to hand off, but then it's not meeting, or it's failing somewhere. Basically, in like that's the condition, or it's like first level of. I'm trying to understand like.
Yeah.
With first level of evals, like when you create a basic test set, or it's after iteration,
It can actually happen both the ways, right? So it might so happen that, like, say you were, when you're creating this entire AI system, you did not even think about the scenario, and you have not even kind of created a rule for the AI system that like when you kind of face certain situations, you have to take a step back and hand it over to a human, right? Or it might so happen that it is kind of let's say you have kind of set certain instructions, but those instructions were not very detailed enough. Let's say you have described certain scenarios, but the AI is not able to kind of understand them, and it is kind of still like in a different scenario, it is a kind of acting weirdly. Or the third scenario could be that like you have already defined all of these instructions, all of these indications, and still the AI is hallucinating, right? So any of the three scenarios is possible in this specific case. Any of the three scenarios is possible.
Makes sense. Yeah, got it.
Yeah. Now, what you do is, right, as the next steps, what you basically start doing is that, okay, you have different open codes you have. Now you have to basically create a clusters of it, right? Because a similar issue that you might be encountering multiple number of times, you might be, let's say, writing different commentary for it. Sometimes the choice of the words is different. Sometimes the length of the sentence that you're creating is different because you're not even paying any attention to, like, how should find, let's say, a certain kind of a rule set of issues, like how should I describe them, etc. And honestly, you should not even worry about it at this stage, because otherwise you'll not be able to do, let's say, very good, let's say, evaluation kind of a job, right? So what you do from here onwards is that, like, you take this open codes and ask somebody to, let's say, create an actual code for you, right? Now, this is a simple step. What you can do here is that you can download, let's say, all of these files, right? You can take the column C, where your all of the open codes are written. You give it to, let's say, any advanced LLM, let's say a Gemini or a Chat GPT, and ask it to simply say that, like, okay, I have written all of these open codes. I want you to go through all of them and create actual codes for the same, right? And our advice is that, like, you exactly use the word which is open codes and actual codes, because these are very well known terms in the field of machine learning, that, like, if somebody tries to read this open codes and ask them to convert to actual codes, what does it actually mean? So an LLM will be able to classify all of the commentary that you have given in the Excel sheet, and will be able to convert them into certain kind of an actual codes, right? And how the response might look like, let's see actually. So because of the paucity of time, let's say I've already created, let's say, some of these things. What you might actually see is that, so for the different commentary that, like, we have used, you can get to understand that, like, what are the different failure categories using the actual coding. It could be, let's say, the customer experience and handoff deficiencies. It could be, let's say, even text and reporting misinformation. And then what you could also understand is that, like, say, of all of the things which are happening in the AI system, what is one thing, like, which is kind of bothering a lot? Or what are the things, let's say, which are going for a toss, let's say, maximum number of times? For example, in this case, you might see that it's the regulatory and legal non-compliance, which is going off the roof 52% of that, 52 times out of the 140 times, right? While, let's say, a text and reporting misinformation, let's say, it's already happening, but it is not something, let's say, which is, let's say, too frequent, right? Now, one thing that will come to your mind after reading to this entire pivot table is that, like, okay, as a PM, I'm supposed to now prioritize. And one framework for prioritization would be, let's simply go and see the counts which are coming and the issue which is happening the maximum number of times. That is the issue that I'll attack first, because I have a limited amount of bandwidth, both in terms of my engineers, and I have limited number of, let's say, budget also available on which I can create an eval system. So I'll simply go and kind of create this entire thing. Now, this could be a good framework to start with, but this should not be your only framework. And in this case, also, you are expected to, let's say, use your PM hat in deciding that, like, how do you decide that, like, what issue should you prioritize or not? Now, let me flip this specific question, right? Let me kind of flip this scenario, right? Let me go to a different scenario where you're creating, let's say, an AI system which is supposed to be used by your leadership. Let's say it's the topmost leadership group that you have in the organization. They will kind of ask certain queries into this entire bot, and they'll get the answers. And depending upon these answers, they'll take certain decisions, right? Now, let's say one of the category of questions that they're asking is that, like, say, what is the growth number of the company looking like? Now, what might so happen is that, like, this entire output is coming out wrong at times, and it is not wrong. It is not the category which is happening, which is kind of encountering this issues the highest number of times. Let's say it just happens probably for a fraction of numbers, which is 1 or 2, right? So you would not want to leave these scenarios, because if you are going to leave this scenario, which is though definitely less occurring, but it is so critical that, like, if a decision is taken on top of that, right, that decision could kind of change the fortunes of a company, right? So even though it is something which is less frequent, you would want to prioritize, and you would want to basically solve it using an eval or any kind of change to the system, because it has very strong implications down the line, right? So again, this kind of a pivot metric that you create after kind of creating an entire actual coding gives you an indication of prioritization, but this should not be the sole prioritization criteria that you're using while you are deciding that, like, what is the problem that I should tackle versus what is the problem that I should tackle later. Okay. Right. Now, the next question comes is that, like, okay, we have taken out all of these traces. In production system, I was able to find approximately, let's say, 1,000 different traces. Now, how should I read 1,000 traces? right? Because no single human or no human can actually go through all of the, let's say, 1,000 traces. So what is the right number of traces, or what is the percentage of traces that I should read in the first place before saying that like, okay, I'm done. I know all of the issues now, right? So in order to understand that, I mean, there is no right answer to it. It also depends upon the judgment and the test. And a simple kind of framework that you can use is that you start reading, let's say, a lot of your traces, and there'll be a point where you'll start facing some kind of a saturation point that, okay, when I'm reading new traces, either I'm finding there's no issue, or even if I'm, let's say, finding an issue, what happens is that like this is one of the issues that I've already encountered in the past while doing this trace analysis, right? So when you start, let's say, encountering this kind of a saturation, and let's say when you read 30 more traces, 40 more traces, and there's either you're not able to find any new issue or you're not able to find an issue from a different category. This is a point where you kind of understand that like, okay, now I'm reaching a saturation point. And even though if I start reading, let's say, more and more traces, right, the number of unique issue categories is something that I'm not able to find. This is where probably you can say that like, okay, I have read enough, and probably I'm now good to go to understand, and I'm now understanding really well that like what are the different issues which my system is encountering. And now I go ahead and start solving them rather than spending my time in reading more and more traces again. Okay, so again, there is no right number that like what percentage of traces should you read, etc. It all depends upon your judgment, but the framework that you can use is that if you read more and more, if the issue starts repeating and no new issues is getting encountered, you kind of stop reading your traces and start focusing upon building the evals. Okay. Coming to the next part. Okay, now what will happen? Okay, that you have done an analysis, that you have read all of the traces, and you say that okay, my system is, let's say, 65% of the times what I'm seeing is that there's a good response coming, right? And now what you're thinking is that like, shall I ship this product also or not, right? Now, what we should focus upon here is that the 65% number, that like how should we kind of gain more and more confidence over it, and did we do any mistakes while reporting the 65% number? Because as let's say product builders, your responsibility will be to kind of, you will be held accountable for the 65% number, right? Now what you can do to be, let's say, more confident in kind of taking a decision whether should I ship it or not ship it, you should, let's say, first account for uncertainty. And what this uncertainty actually means, we will kind of understand in detail in the next slide. What it actually means is that like, if I rerun the analysis again, whether I'm again going to get the 65% or the acceptance rate for this specific AI system that I'm going to build drops to either 55% or it increases to 75%. How can I be, let's say, more and more confident, right? Now, when I'm looking at this, let's say 65% kind of a number, did I ensure that I was looking at all of the possible queries like which a user is coming, or I'm basically being more and more lenient that like for even, let's say, very complex, for very easy queries, I'm getting a 65% success rate, but there's no representation of any complex queries in the dataset that I've just consumed, right? And the third thing that you should be also mindful of the fact is that at the end of the day, LLM is also, your LLM as judge is basically also an AI system, is also an LLM, which also tends to hallucinate. So whatever variance that I might see, let's say in this 55 or 75, is it because of my AI system, or is it because my judge is behaving erratically? And if it is expected to behave erratically, how do I go and control the same? Right. So these are the three things that you should immediately do after establishing any kind of an acceptance rate or any kind of a success rate from your trace analysis. Now let's go and understand this step one by one in deep. Okay. Now let's take the first scenario that, okay, my success rate was 65%, but how can I be very sure that like it cannot be, if I kind of rerun it again, it cannot be, let's say, 55% again or 75% again, right? So there you basically use the concept of confidence interval and say that like I will establish my success rate with certain amount of confidence interval, right? Now there are multiple mistakes that somebody can do, right? What somebody can do is that like they might run actually very limited number of trials, say that okay, I will read only 5 trial steps, and if on this step I'm basically finding 2 successes, my success rate becomes 2 out of 5, which is 40%. But the moment, let's say, I do a 6th trial step, right, what might so happen is that, let's say, if the 3rd, 6th trial also succeeds, so your success rate immediately jumps to 50%, or if it fails, your success rate just comes out to be approximately 33%, right? So how can I be very, very sure that, like, say, when I'm going to, let's say, do one more turn, right, this number does not change a lot, this number does not, let's say, fluctuate a lot, right? Now, this is where the concept of, let's say, confidence intervals starts coming into place. So whenever you're quoting a success rate, first ensure that, like, you're basically creating batches with high number of trials so that you are allowing enough number of results, or you're processing enough number of results to establish the success rate, like, for the platform, for your, let's say, kind of an AI model, and always report it, let's say, with some confidence interval, right? So if your confidence interval is coming out to be very, very wide, let's say you can say that, like, with 95% certainty, I can say that the success of my confidence, or the success of my AI system is ranging between, let's say, 60% to a 95%, right? This means that, like, still there is a very, very wide uncertainty, and if you go ahead with this kind of an AI system, you can get landed anywhere between, let's say, 60% and 95%. So it probably is not a very, very good criterion for you to go ahead and ship it. You should try to kind of remove this uncertainty, let's say, from your system. But it might also happen that, like, you could say that, like, okay, with 95% confidence, I can say that my accuracy, or let's say my success rate of this entire AI system, ranges between 65% to 70%. That is a better state to be in, rather than being in a state saying that, like, okay, I'm ranging between 50% to 95%, because it is very uncertain at this point in time. Okay. Now, the second point that we just spoke about, that, like, okay, now I'm very confident that, like, even if I'm trying to do a rerun of it, I have tested it enough, and this is, like, how the range of my success rate is going to look like. But did I also check this specific AI system across different scenarios? Because let's say if somebody says that, like, for a hospital, the surgery success rate is 90%, right? Now, what if, like, the success rate is nothing but a weighted average of all of the different kind of surgeries, let's say, which are happening, right? Let's say for a simple appendix removal, the success rate is could be 100%, but for any open heart surgery which is happening on this hospital, the success rate could be, let's say, as low as 40%. Right? So this is not a very, very good scenario to be in, right? Because a customer would come saying, expecting that, okay, 90% the success rate, let me go and do a, let's say, open heart surgery. But he's not even aware about the information that, like, if I go for it, the success rate is the expected success rate is only 40%. Now, in these cases, what you can do is that, like, you can try and basically take these stresses and do this success rate analysis for different kind of complexity scenarios, right? Now, again, I'm taking the shopping bot example, which we have discussed at the very, very starting. In this shopping bot example, also, you could think about, let's say, multiple query types, and these query types could also be, let's say, having different range of complexity, which they are supposed to handle. The first thing could be exact queries, right? So let's say you go to the PDP page of any kind of a of an e-commerce platform, or let's say even you go to the chatbot and say that, like, okay, show me the options that you have available in iPhone 15 Pro and 256 GB variant. And it could be, let's say, either of black in color or blue in color, right? Now, what might so happen in such cases is that the query is not very complex, because user is not giving an open-ended task, let's say, to an entire bot. It is simply saying that, like, I want something which kind of matches the description, and the kind of errors that your AI system could face is also something which is not so major, right? So it could, in place of black, let's say, it could actually fetch a white item, right? Or it might not even fetch an iPhone altogether. It might actually fetch a Samsung Galaxy phone, because iPhone is running out of stock, let's say, for example. Right? Now, the second set of queries could become, let's say, slightly more exploratory in nature, that user often has a goal, but it does not have a fixed product in mind, right? So the amount of ambiguity increases, let's say, from here to here. It says that, okay, I need a best phone which is available under 30,000 budget, right? Now here, what could go wrong, right? That lot of irrelevant products might starts coming, right? Like certain phones, let's say, which have a very, very poor rating. Those are the things, like, which it starts coming, right? It might also happen that your AI system starts missing a lot of budget constraints. So there are certain phones which are 35,000, 36,000, 40,000, right? So here, what we are seeing is that, like, from this scenario to this scenario, the amount of complexity further increased, right? Now, the complexity could further increase, let's say, in certain set of queries. There could be certain long tail queries also, where the user is expressing very, very nuanced needs, right? So user says that, I need, like, an office chair for the lower back pain that I'm actually encountering. It should be, let's say, under 10,000 rupees, and it should be, let's say, very, very ergonomic, right? Now, this is, let's say, very, very complex products, right? It might so happen that the products that the AI system starts kind of sending are not even chair. Let's say they are sofas, or it is kind of returning very, very generic items, which does not even take care of this ergonomy, or this does not even take care of the solution, let's say for this back pain problem. So whenever, let's say, we are doing this entire success rate establishment, we should also be mindful of the fact that, like, when we are trying to establish it, how do I establish it across different segments of the problems which my AI system is going to encounter, so that I'm going to give a, let's say, very, very clear view to my users, to my leadership, to my, let's say, stakeholders, that for, let's say, for exact queries, my success rate is 90%. For exploratory queries, let's say my success rate is 80%. But when it comes to long tail queries, I'm still kind of meddling between 40-50%. And this is like how we are go. And we have a plan to basically solve it, but this is the state right now. So do not, let's say, get too much influenced by that 65-70% number that you have. And this is the kind of clarity that we can establish to our stakeholders, so that they also have a very clear expectation that, like, in such cases, you are expected to work fine. But when such cases comes, which are also very complex to handle, you are going to encounter certain issues. Okay. Let's move to the next slide. The third point that we spoke about, that, okay, my variance is coming, right? Sometimes I report it as 65%, sometimes I report it as 62%, sometimes I report, let's say, it is 60%, sometimes it is 70%, right? Now, I think so far all of us agree that in this kind of a system, or in this kind of a situation, both the ends, like, which is an AI system, which is also built on top of an LLM, and a judge, which is, let's say, also an LLM, right? Both tends to hallucinate. And it might so happen that, like, a part of the variation in this success rate could also be coming because of the LLM as judge and its randomness that it is trying to basically throw in, right? So what you can do is that, like, you cannot completely make it zero, right? Because at the end of the day, it is also an LLM from your end. But as a builder, you can keep certain thing in mind that, like, if I set certain parameters in my LLM, and if I fine tune certain parameters of my LLM, at least I'm kind of controlling the possibility that it is going to be a lot creative, and hence it is going to kind of give me a lot of, let's say, varied results, right? So there's a parameter which is basically called as temperature, like in this different LLMs. Now, what this temperature actually does is that it basically controls the randomness or the creativity, let's say, in LLM outputs. Okay. So this is a parameter that, like, we can go and basically fine tune. Now, when the temperature setting is basically set to high, what LLM tends to do is that, like, it tends to understand that, like, okay, user is asking for more random and creative responses. For example, if I have to write a blog describing that, like, how good Kashmir is, or let's say how good probably any hill station in India is, right? I would actually want the model to be as creative as possible, because I do not want it to be, let's say, very, very boring. So I'll basically set the temperatures, let's say, very, very high setting, right? But if I'm looking for a more focused and deterministic kind of a task, the task that we are trying to do, let's say, exactly in these evals, where we are asking them to judge a certain response, we do not want them to be creative, and hence we would want to keep the temperature setting to as low as possible. The temperature ranges between 0 to 1. We can actually keep it 0 in case of evaluation task, because we are looking for very, very deterministic outputs. Now, somebody could say that, like, okay, I have set 0 temperature. Now I should basically expect 0 variance in the results, right? Now, a 0 temperature could also result to non-zero variances, because when you're going to, let's say, use this LLM as judge in different settings, and different settings within different batch sizes, different hardware configurations on which the entire system is going to run, research says that approximately 92 to 97% of the times you are going to face consistent outputs, but still there's a probability of 3 to 8% where you might get different outputs on rerun. So even setting the temperature setting to 0 does not take all of the judge related variance out of the equation, because it might still happen approximately 3 to 8% of the times. Okay. Let's move to the next part, which is now that we have talked about that, okay, how do I do a trace analysis? How do I kind of establish a success rate, etc., etc. But let's also talk about that when the entire architecture of the system changes, when you're talking about, let's say, a simplistic kind of a thing, which is, let's say, a translation kind of a query, versus when you go to architecture where you're using a RAG module, versus, let's say, when you go to an adjecting kind of a structure, how does the entire nature of evals changes? And we will today deep dive, let's say, on the RAG wala topic, that, like, if you have to think about evals for RAG, how should you think about it? Okay. So first, let's understand that, like, why the evals for RAG is something which is very, very different. So just kind of having a very quick refresher of what the RAG is. So RAG model is nothing but it is called as retrieval augmented generation. What you're trying to do here is that, like, you're not trying to rely upon the open world knowledge of the LLM. Rather, you are trying to ground the knowledge of the LLM within a confined boundary. Let's say some kind of internal documents that you have, some kind of policy documents that you have, and then you are basically asking the question. You are basically taking the question from the user and redirecting the LLM to respond to this particular user question by saying that like, okay, these are the relevant knowledge documents that you should refer to. So any kind of, let's say, RAG module is a two-step process that based upon the user query, let's say the user says, again, I'm going back to the same example, that what is the returns policy for electronics? It is supposed to retrieve the right documents from the right policy documents from your organization. And once it has retrieved it, it is supposed to, let's say, generate it. Okay. So a simple pass-fail judgment on the output is not sufficient because you have to exactly understand if the retrieval is happening, if the error is happening in retrieval, or if the error is actually happening in generation. Because if you have retrieved the wrong document altogether in the very first place, there is no way the generation is going to work fine. If you are retrieving wrong documents, generation is also going to go for a toss. Okay. So very simple example, let's say you go and order a pasta like in any restaurant, right? And like you will only get pasta in the very, very first place if the person who was doing the purchase for that restaurant actually shop for the right ingredients, right? And if ingredients were actually used correctly by the chef to actually cook you the pasta, because if the chef did not even have the right ingredients, there is no way you are going to get pasta served in the restaurant. Okay. Now let's come to the retrieval part a bit. That okay, I understand really well that for a RAG kind of an architecture, I'm supposed to retrieve the right quality of, or say the right set of documents. And once I have retrieved that, then only I should basically think about generation. But how do I understand that like I'm retrieving the right set of documents in the very, very first place, right? So in the typical, I think workspace, many people kind of assumes that okay, you do a similarity search and similarity, and if your user query is very, very similar to the document that you are kind of retrieving, it's a good enough proof that like you're retrieving the right document, right? But it is not always the case, right? So let's say if I simply say that like I'm going to calculate a similarity. So what do I mean by similarity is that I'll take the user question, which is let's say mobile conversion, and I'll check the retrieved document if there's a similarity between these two. And how do we calculate similarity? That I'll kind of convert this entire thing into some kind of an embedding space. I'll convert this entire document into some kind of an embedding space, and then I'm going to, let's say, use a cosine similarity, which is simply like a representation of saying that if you were to plot this embeddings, let's say in a vector space, how closely these query and this document are going to come. And if it is kind of meeting a certain threshold, let's say that threshold being 0.8, I'll say it was the right document which my RAG module is going to get retrieved, which my RAG system is retrieving. But it is not right always, right? So it might so happen in this case is that a user is trying to ask that like, okay, for my e-commerce platform, if a user comes and shops from my mobile app, what is the conversion rate? And the retrieved document that you are taking here is that which it talks about the desktop conversion, right? Now, why a similarity score is high here? Because both of the documents are talking about conversion, but the entire context changes. One document is talking about mobile conversion. So the query is about mobile conversion, and the document that you are receiving is about desktop conversion, right? Desktop conversion, right? So even though like there's a high similarity, but the relevance between the user query and the retrieved document is still very low, right? So in all of these cases, in place of just using the similarity metric, which can often go at toss, you should basically start using following metrics to understand that what is the retrieval quality of your RAG system. The metrics are basically precision at K, recall at K, and MRR. We are going to dive deeper now into each of the metric to understand that like what this metric actually means, and in what kind of cases, what is the metric that you should focus at. So it is not always the case that like you should try and basically balance all of the three metrics. Depending upon the scenario, you might have to choose one metric and then try and optimize for it. Okay, let's go to the very first topic, which is precision at K. First, let me just explain that like what do we actually mean by precision. So just forget all of this text, just focus upon this diagram itself. Let's say you are working in some kind of a bank, right? And you are creating an ML model where you are trying to predict that like, okay, of all of the transactions which are happening, how many of the transactions are actually fraudulent and how many of the transactions are actually non-fraudulent. right? So let's say that like each and every dot is representing a transaction, and the orange dots that you're seeing are actually the fraudulent transactions. And as you can see also that, right, in any kind of an ecosystem which is happening in the finance, many of the users are genuine and there are only some bad apples, and hence you are seeing that like the number of fraudulent transactions are lesser here, right? And what your model actually does is that like it tries to kind of predict that like, okay, what was a fraudulent transaction versus what was not a fraudulent transaction. So what your model is doing is that there were some actual transactions. There were some transactions which were really fraudulent, and it predicted also them as fraudulent. Okay, these two were fraudulent, and I'm basically calling them as fraudulent, right? But there were certain things which were also non-fraudulent, which were also fraudulent, but your model predicted them as non-fraudulent, right? So this is like say the one instance that we're talking about. In fact, there were also cases where it was not fraudulent at all, right? It was not, it was green in color, but it actually predicted them as fraudulent. Okay. And there were cases where it was actually non-fraudulent and the model predicted them as non-fraudulent or not, right? Now, what do I mean by precision is that precision is nothing but like in a very simple English terms, it kind of understands that like, okay, whatever you have predicted is fraudulent, what part of it was actually fraudulent. So if I just try and kind of describe it in the academic language, it say that like what is the ratio between true positives and a summation of true positives and false positives, right? So in this case, all of the orange dots which are lying in this quadrant are true positives because they were actually fraudulent, and our model also predicted them fraudulent. So they were detected, positive correctly, right? The second case like are these two, let's say transactions where though we predicted them as fraudulent transactions, but they were not fraudulent transactions. So we kind of labeled them as positive in a very wrong manner. So what I mean by false positive is that, let's say if this model was entitled to predict something as fraudulent, it predicted them as it predicted these two cases also as fraudulent, but these were false predictions, and hence we are basically called as false positives. So you typically calculate this number, and in this case, it is going to come out to be, let's say, 2 by sum of this plus this, like which is 4, is going to, let's say, come out to be, let's say, 50, right? Now, this kind of a metric becomes really important for you when you have a very small context window. Okay, so what I mean by small context window is that, let's say there are different LLMs that you use, and every LLM ka context window is different. For example, somebody supports 100K, somebody supports 1 million. People are even saying that like Mythos is going to support 10 million and above, right? But if you have a low context window LLM, then this precision becomes really important for you, because if you were to, let's say, fetch 3 different documents, and out of 3 documents, 1 document was wrong, right? Or 2 documents were wrong, then your retrieval itself has gone for a toss, and your generation is not going to happen correctly, because the model cannot even read, let's say, beyond than 3 documents or 4 documents. So you have to kind of optimize the precision here, right? Now, the kind of examples that you'll see, let's say in a real world scenario, is that these are basically low latency production systems, because if the model is not supposed to kind of process a lot of information, and you're supposed to, you are asking the system to be, let's say, very responsive, these are the cases where this kind of a precision metric starts playing a role. And the another thing is that, let's say you're building an AI system on edge, let's say on your device model itself, it is not kind of calling an external model, and you're trying to host a model, let's say on a device itself, where you're expecting that like you'll not be able to kind of create a long context window because the memory available in the device itself is very low. So these are the cases where precision becomes really important from a RAG perspective. Okay. Now let's go to the another concept, which is basically recall at K. Now this kind of a metric becomes really important when you are basically taking a very high stake decision, right? So let's take, in this case, we are trying to build any kind of medical chatbot, like which is going to be, let's say, used by doctors or patients, or it is kind of a legal chatbot which is going to be used by different lawyers, right? Now let's keep this situation arise. First, understand that like what is actually meant by recall. So again, I mean, discard all of this particular text. Now, let's say you're building an ML model, where your job is to predict that like, okay, I'm trying to analyze certain cells, and depending upon these cases, I'm going to classify that like whether it's the case where cancer is actually there or whether the cancer is not there, right? Now, again, like, so what might so happen is that in this case, there are the orange dots represents the cases which were actually cancer cases, and the blue dots represents the ones which were actually non-cancer cases, right? So let's say your model output is coming like this. where out of the three cancer cases that were available, let's say in this data set, you are able to predict two of them correctly, but you are not able to, let's say, predict the third one, right? Now, why it is a very, very high stakes decision? Because let's say if the outcome and the livelihood of the patient, and if the, let's say the life and death decision of the patient depends upon this model, we are not doing a very, very great job, because if this model predicts them as, let's say, non-cancerous, the medication will not start, and it might turn out to be, let's say, a very, very fatal scenario for that specific patient, right? And hence, in this case, it is very important for us to kind of measure the recall. And how do we measure the recall? We try and understand that, like in a very simple English terms, we try to measure that of all of the possible positive cases that were there in my ecosystem, how many of them was I able to identify? So simply, if I put them in a very, very academic manner, I will say that what is the ratio of true positives and divided by the sum of true positives and false negatives, which in this case is nothing but 2 divided by 2 plus 1, which is 3, and it comes out to be, let's say, 66%. So in all of these cases where it's a very, very high stake decision and you're trying to, let's say, create a model of yours, it becomes very, very important for you to kind of optimize for this, let's say, metric, which is, let's say, recall it. Okay. Now let's basically go to the third particular concept, that like what if like I'm trying to create a situation, or I'm trying to create a model where not just the retrieval matters, but the retrieval position also matters, right? So I'm going to, let's say, tag back you to the example of the shopping board that we are building, right? Now it says that, okay, help me find, let's say, certain mobile phones with certain kind of a description, right? This is the query like which is coming in onto our platform, right? Now what might so happen is that like it does not matter that whether you are let's say, retrieving all of the right products. It also does matter that like what is the rank of the right product which is there in your system, right? Let's say there's a search query like which you are basically finding on any of the platform, right? And the search query says that mango 250 grams, or let's say mango 2 kg pack, right? Now if that mango 2 kg pack does not come at the top, right, it comes somewhere, let's say, in the bottom, and again all of the results are mango itself, that is also not a very, very good outcome for you, because the customer was exactly looking for, let's say, a 2 kg mango pack. And if it does not come on top, if it comes, let's say, somewhere in bottom, maybe your conversion is going to take a hit on the platform, because user would say that, Acha, there's no 2 kg pack which is available on this platform, let me go to a different platform altogether, right? So in the mean reciprocal rank, what we do is that like we also try to basically figure out that uh, that what was the rank of, let's say, first relevant document, right? So in this case, like if I was able to find the first relevant doc in the very, very first place, the MRR value becomes 1. And the moment I'm actually going to find it at the 10th place, the value becomes 0.1. So as and when, let's say, my rating, or let's say my position of the relevant document starts going downwards, the value for basically MRR starts decreasing. And this kind of a use case is something which is applicable for any kind of a search shop bot, or any kind of an FAQ chatbot, where I say that like, okay, I'm not able to return this item, and it is going to give you, let's say, a list of different FAQ questions which are already available on the website, right? And if the question, or if the FAQ which talks about the return policy is placed at 3 or 4, it is not a very, very good situation, because ideally you would want to comment on the top. Okay, so MRR is something that you kind of look at those cases where not just retrieval is important, but the relative position of the retrieved documents also plays a role, like say, in the overall user experience. So this is, let's say, a quick summarization of what we have just discussed, that depending upon the different product type, and depending, you have to kind of choose the right metric that you're going to use for your use case, for your RAG use case, whether it is going to be recall, MRR, or precision, and what is the reason for the same. Because in case of, let's say, medical record search, you would not want to miss any important report, because the outcome could turn out to be fatal. In case of search results, you would want that the most relevant product should be placed right on top, and not, let's say, somewhere in the between. And for the LLMs, where you're trying to basically operate with short context windows, the precision becomes really important, because even if you're able to fetch one non-relevant document and fetch it to your LLM, the generation could actually go for a toss, because LLM in itself has a very, very small context window. Okay. Any questions so far?
Yes, I have one question.
Yeah.
So in terms of ranking, right, you mentioned main. So because I'm confused whether this is a metric, or I've also seen like top K ranking, which means that, and that K can be like top five documents, right? So are we saying ranking between, like, let's say the value is 5, ranking amongst that, or where does it fit in? Like, I'm just not able to.
So what this actually means is that, let's say, again, like you can define that, like what are the top positions that you're going to consider, right? So let's say you're saying that like you are going to understand, you're going to find that like among the top 10 documents which your model is retrieving, what is the relevance of the same, right? So within top 10, like if you're able to find it at the very first place, you will say that my MRR is 1. So my mean reciprocal rank is 1, because in the very first instance itself, I was able to find the right document. Okay. But let's say if you're able to find it at the 10th position, you will say that like, okay, at 10th position, I was able to find it. And hence like my score contribution becomes, or hence my score for the specific retrieval becomes 0.1 and not 1.
Got it. So is it similar to NDCG, which is normalized, discounted, or is it something else?
Yeah. So it is some, sorry.
Yeah,
Was
go
there
on.
a question?
No, go on.
Yeah. So it is somewhat similar, but it is not exactly similar, because let's say in kind of an NDCG setting, right? Like what you are trying to do is that like you are trying to, let's say, discount for all of the positions, right? So let's say if the document comes at the second position or third position or fourth position, right? Accordingly, your NDCG score is going to get changed, right? That like even if it comes at second position, it's okay for you. Even if it comes at fourth position for you, it's okay for you, and it's going to get reflected, let's say, in the NDCG score, right? But when, let's say, you're reporting an MRR score, right? You are exactly, let's say, wanting, like if you're exactly wanting that specific product to be, let's say, on the top, right? Let's say that like I want to build a system where the first document has to be relevant, right? Or like among the two documents, like it has to be relevant, right? This is where MRR becomes more and more important, right? Because NDCG, like even if it comes at, let's say, to the 15th place, it is going to kind of reflect and score, right? But in MRR, you can kind of cut short this, that okay, I want my top document to be, let's say, the rank first document, and what is the score that my retrieval model is actually fetching me.
Got
So
it.
this is the nuance.
Understood.
Yeah.
Makes sense.
Yeah, but actually, like the NDCG, that is normalized discounted cumulative gain, and this MRR, it is sort of depicting the same thing. Like if you have the search recall, it talks about like whether the recall set is correct and in what order it is coming, right? So based
Yeah.
on that, we identify whether the ranking of the system plus the relevance of the system is good or not. So it's
Got
both are very, very similar.
got it. But I think for RAT, this makes more sense than
Ye-
NDCG, basically.
Yes, yes.
Understood. I have one more question, but it's more on the last section. I can cover it later also, but let me know.
Yeah,
Sure.
you can ask now
Okay,
also.
so when this is more around how do we think of designing evals for a system that is starting from scratch. For example, voice bot. Okay, now in that voice bot, there could be, so one way to think about is that, hey, I'm going to cover different personas, but that like the first set of eval is going to be really complex, right? That boundary of it, because there could be anonymous question, there can be long term question, there can be so much, right? And I'm thinking from a 0 to 1 approach, not from the second. That till what criteria, till what extent you will go about it. Because at the first time when you create, you wouldn't have a lot of queries, right? Like the
Yeah.
data that you want to choose. So what I do is I'll go to the LLM and I will go about it. But or what I've done is basically created personas and then created like different dimensions around it, and but still, like what is that boundary, like how do you think about strategizing this approach that for this will be my set of evals for my first iteration where I want to achieve most of the things, if that makes sense.
Yeah. I think it's a great question, Aishwarya, right? And there's no right answer to it. At least the approach that you can take is that say whenever you're thinking about this problem statement, the number of user stories that you can think about, right? At least all of them should actually be a part of your eval suite, right? Because again, like if it's such an open-ended product that you might be only able to think of approximately 100 scenarios, where in total, let's say there are approximately 140 scenarios like which are happening in the platform, right? So at least try and contain those 100 scenarios in the very, very first go, right? And then try and basically understand that, like say, as the model goes into production, understand that like what are the 40 different scenarios which are also coming into equation which you have not handled for, and then trying in basically add it, let's say, in your eval, right? For example, one thing that was really, really surprising to us, let's say in one of the use case that we were building, is that like we were trying to build recommendations which should have, let's say, some specific colors coming in, right? So like, let's say if I'm saying that for a specific product, let's say another product should come, but it should also define that like what color the product should be, right? Now it was such an obvious question that like when we were writing evals, right, we did not even think about it that like this kind of error might come. Maybe it was a miss on our side that we did not kind of create a whole suite of responses that I might get to see. But when we start reading traces, like what we were able to understand that for good 3 to 4% of my cases, my recommendations are coming without any color variant of it, right? Which was like a complete no-no for us, right? So again, let's say we started with some amount of understanding that we had, and you put into a production, let's say for a small set of an audience, and you then try and evaluate again and again that like, are you getting any more type of an errors coming? So it's more sort of a continuous process rather than, let's say, a process that you just start and probably reach to the end. It's a process which will keep on evolving.
Yeah, makes sense. Yeah, so I think what you're saying is go based on use cases rather than personas or let's say queries, etc. type.
Correct.
Makes
Yeah.
sense.
Okay. Now, whenever, let's say, you're creating any kind of LLM as a judge, right? So what exactly are you going to use? Like, say, how does the process looks like? So again, like say, this is like a simple 3-step framework that you can use. First, you should understand that like what is the rubric, or say first you should even understand that like say what is something which makes a good or a bad response, right? So this is always mentioned, let's say, as part of your prompt only, and you can also include as some of the few examples that you would have to basically tell LM that like, hey, this is like how a good response look like, this is like how a bad response looks like, right? Then what you also need is basically LLM to act as a judge. You can definitely, let's say, put any off the shelf model, let's say, which is available, and you can feed this prompt to you can actually feed this kind of rubric to this LLM to basically act as a judge. Now, question that comes, right, that like what kind of a model do I use? And again, there are two school of thoughts here. Different people have different opinions. Somebody says that like if I'm using, let's say, a Gemini 2.5 for my AI system creation, my judge model should be Gemini 3.0 because it is more superior, right? But this versus there's another school of thought where it says that if I'm going to use, let's say, a different prompt altogether, why does the model matter? Because the response was generated by Gemini 2.5 with a specific set of instructions given to him, and when I'm going to judge that instruction depending upon, let's say, the same, which is Gemini 2.5 model again, since I'm using a different prompt altogether, so why does it matter? Again, like there are two different school of thoughts. At least fundamental belief is that like if you use a superior model, it is expected to act better because there'll be definitely lesser number of hallucinations, more number of context window. But depending upon the use case and the cost considerations that you have, you can definitely go with, let's say, any of the models. Definitely do not go with, say, less evolved model at all. That like if your base AI system is operating with a Gemini 2.5, you should not do the evaluation with Gemini 2.0. You can definitely knock off the tasks such as very deterministic tasks using code-based eval and off-the-shelf ML models, but do not, as a practice, generally people do not use, let's say, a lower kind of a not so advanced model than the model on which the AI system is built, right? Now, this is also, let's say, a very important part where when you're going to get the LLM judgment, how, in what format you should even get it, right? So the judgment should so the judgment that is basically coming from LLM should not just contain like a pass or fail kind of a thing, but it should also kind of ask the LLM to say that like what is the reasoning, on basis of what reasoning you are able to kind of say that like whether it was a yes or no, right? Because when you read lot of these traces, you are also able to understand that like how LLM is thinking, and the way you could have programmed this LLM as just to act could itself be wrong, and hence it gives you very clear indications that like what to fix, what not to fix. There's a trade-off here that when you're asking for, let's say, a very detailed description of how did LLM went about, let's say, thinking for the same, there's a cost implication because you're burning more and more tokens. And from a user responsiveness perspective, also you're increasing a lot of latency because now LLM is not only just doing one task, it is doing the task of a judgment, and it is also doing the task of a generation, right? So it is going to add to your cost and latency, but it is something like which is advised that you should do and should not skip that specific process. Again, this is something that like you spoke about, that like you have to define like a role, you have to give certain kind of rubrics, you have to basically provide a certain examples. So we have a sample prompt which I just want to kind of flash for a few seconds before we go on to the next topic, that like how should it look like. So let's say in the same example, if I have to kind of create an eval for the hand of deficiency, we can first describe that like what is the role, we can define that like what are you supposed to kind of act, and we can define certain rubrics that like this is like how you're supposed to act, and this is like how you're supposed to kind of provide an outcome to it, right? Again, like in this example, probably I think we have not written that like you should also provide a reasoning for the same, but that is something which is advised to be added like as you kind of create your own evals. And then you also add, let's say, a few short examples of that, what are the scenarios that you're expected to encounter, and in case such scenario happens, how should you act and what is the right response, so that the LLM has some kind of an understanding of how you're asking it to behave. Now, moving on, right? Now, the next question comes that, okay, I have 100 traces. I have all of those 100 traces actually validated by an SME, right? Now, how should I make use of these traces, right? Because this trace data, which is validated by an SME, is the golden set of information that you have available, right? And you should always try to use it very, very judiciously, right? Now, so far, with whatever discussion that like we have done, what we have covered is that now we have an AI system, and we have even created some kind of an AI evals for it, and now we are trying to kind of do and we have even kind of we also have the trace logs, etc. available. But how do I use this trace effectively is also a thing that you should keep in mind, right? So imagine that like you have approximately 100 traces which are already, let's say, labeled by a human, that like what is a good response, what is a bad response. Typically, whenever you're creating your LLM as a judge, you should only use approximately 5 to 10% of it for the training purpose, right? So if you see, let's say in the prompt example also that we have just showcased you, we've just used, let's say, about 5 to 10 examples to just give LLM an idea that like how it is actually performing, right? We should not kind of exhaust all of your traces, let's say, in the future examples itself. And once you have done the same, you'd start fine tuning it, and you should use, let's say, the remaining 45-50% of the traces to fine tune it, right? So what you will do is that you have this particular prompt, you will again, Ashwarya, to your question, that like you will actually feed it to the actual to the traces, to the remaining 50 traces, and understand the responses, that like how the judge is behaving, right? And you will start encountering certain places, okay, this is probably like an example, or this is like probably a scenario that I missed, let's say, in my rubric, and let me kind of go and correct it, right? Now, once you have fine-tuned it, so you have used approximately 10 examples for the LLM to understand that like how should it behave, and you have kind of run that prompt acting as LLM as judge for the remaining, let's say, 45 to 50 responses to understand that, let's say, how do you fine tune. Now comes the remaining 45 to 50% of the traces, where you should try and understand that like, okay, what is the results like which are coming. Okay, so now you have created your LLM as judge. You have also fine-tuned it after observing that how the things are coming and what I need to tweak, etc. in my prompt, or do I need to add more examples, etc. But in the test data, this is like where your actual validation comes, where you try and understand that like, okay, how good is the LLM as just performing, right? Like how good it is actually coming out to be. Right. And you should not use this test data to kind of fine tune your prompt, because if you're trying to do that, you are basically overfitting to the test data. You might see that, okay, my LLM as judge is now becoming 90% effective, 100% effective. But since you have overfitted the test data on the same, it is supposed to happen, and we are going to expose it to, let's say, another 100 traces. Let's say your success rate of 60% or 90 fall to 60%. So this is like a practice you should completely avoid. Never use your test data to just use your test data to validate the results of LLM as judge. Do not feed it as examples back to the judge again. Yeah.
One question, sorry.
Yeah.
So when you say basically not feed your test data, is basically you can make improvements in the prompt, right? But
Correct.
Okay, got it.
Yes. Yeah. Now, at the end of the day, right, let's say, what do we want? What does LLMS judge is doing, right? It is trying to basically create a judgment, and we are trying to evaluate the quality of the judgment, that like if a human were to kind of evaluate it, how would it look like, right? Whether my LLMS judge is probably acting as Apur or Shailesh or Ashwarya or somebody else in the room, or it is completely, let's say, behaving very, very randomly, right? Now, what might so happen that, okay, so far you have beautifully done this trace analysis. You also have an LLMS judge's place. You have your golden data set available, which is labeled by a human. You also have, let's say, the responses which is coming from the LLMS judge. And we are trying to compare that, okay, if I compare the human labeled data as compared to LLMS judge, 70% is the chance that my LLMS judge is basically agreeing, let's say, with a human in the room. Okay. Now you say that like, okay, 70% times my agreement is coming. Now, is it like a good LLM judge, or is it happening, let's say, purely because of some chance or some true agreement, right? So this, just the agreement rate between, let's say, a human and an LLMS judge is not the right metric to kind of represent, and hence we should go to something called as Cohen's Kappa, right? So this is like a typical metric which is used in the academic world. And the value of this Cohen kappa basically lies between -1 and to 1. And what it tries to help you understand is that, like, what is the rate of agreement? What is the true agreement between two raters? Because it might so happen that, let's say, if I'm rating and another person in the room is also rating, sometimes we are reaching to an agreement purely because of a chance, right? And what this metric actually does is that it takes out that element of chance out of the equation, and it says that, like, if I were to remove all of the randomness, okay, how good is the agreement between the two raters? And in this case, the two raters being your LLMS judge and the human label data. So now let's understand that, say, how do you calculate this metric? This metric is nothing but a calculated as a ratio, which is nothing but P0 minus PE, where P0 is the observed agreement, that typical 70% value that we just spoke about, which is like nothing but like you put a formula in Excel that, like, if the response of both human and LLM meet kind of matches, that is our observed agreement, right? And then you knock off the expected probability, which is P, right? Now, how do you calculate this expected probability? What you do is that you basically you take the probability where both LLM and human as judge is basically passing the agreement, right? And then you sum it like with something called as with the cases with the probability where both your human and LLM was basically kind of negating that particular kind of a statement and saying that it was not handled by the AI system correctly. Again, you need not kind of calculate it manually. There are multiple, I think, libraries available to kind of calculate it, let's say, for you. But it essentially says is that from the observed accuracy, if I knock off P, which is nothing but the summation of the probability when LLM as judge found a response to be good, multiply by the probability when human as a judge found the response to be good, and I sum it, let's say, with the probability when LLM as judge found the response to be bad, and the probability when when human as a judge found the response to be bad. This is like, say, how we calculate the P. And then this ultimate ratio when you calculate is something which is basically called as Cohen's kappa, right? And when you basically get the score which is expected to between -1 to 1, this is the sheet that you can actually use, that, like, if the value of kappa is lesser than 0, the strength of agreement is something like which is very, very poor. It is even less than chance, right? And till the 0.6 right number which is reached, the strength of agreement is something like which is not very, very great, right? And it is like, say, numbers which is beyond 0.6 and 0.8 where the substantial agreements actually starts coming, where you can confidently say that, like, okay, now I'm very, very sure that, like, say, whatever judgments my LLMS judge is giving, it is in accordance with the human judgment, and it is not happening purely because of chance, right? So you can use this kind of a rubric to understand that, like, say, how do I calculate my Cohen's kappa, and how do I ensure that, how do I report the agreement of my LLMS judge, like, with a human kind of a model, right? Typically in industry, what people do is that, like, if it is lesser than 0.6, we kind of conclude that the judge does not agree, let's say, with the SME at all, right? And if it is, let's say, between 0.6, 0.7 to 0.6, we basically take a judgment basis call depending upon what the product we are building, and, like, say, what is a good thing, or what is a good state for us to kind of ship also or not. And if it is greater than basically 0.7, what we say is that, like, judge is now good to ship. It is almost in kind of agreement with, like, how a human would be rating this entire evaluation, and we should kind of go ahead and kind of ship this LLMS judge. Okay. But there are also cases where the actual agreement could be high, but the kappa could be, let's say, very, very low. And again, this is like a slightly advanced topic. We'll just cover the very, very surface of it. So let's say if you have a very, very imbalanced data set. And what do I mean by imbalanced data set is that the data set itself that we are kind of using contains most of the things which are of good quality. Let's say you're doing a safety evaluation saying that, or let's say you're kind of creating a system where LLM is kind of coming out to be true most of the number of times, right? So a human is also going to say that, like, okay, AI system did a good job. And let's say your LLM judge is also basically going to say that like, okay, AI system did a very, very good job. So let's say 95% of the responses are good and only 5% of the responses are bad, right? Now, what might actually happen in this case is that the value of P will actually become very, very high, right? Because what is P? P is nothing but a summation of that. What is the time, let's say when both were basically saying it was good, and plus the summation of what was the time, let's say when both were basically saying it was actually bad, right? So the P of good is going to be, let's say, very, very high. The P of bad is actually going to be very, very bad. And hence the overall P will be, let's say, closer to one, almost closer to one, right? Now, in this case, what will actually start happening is that the value of P will start becoming, let's say, very, very low. Okay, because, and we might kind of feel that, okay, this entire agreement which is coming between the human and the LLM judge is purely because of, let's say, some random agreement, and they are not agreeing in reality. It is some randomness because of which they are agreeing, right? But it is a wrong inference that we are taking because it's an imbalanced system that we are looking at, that every response is either so good or so bad that both of them are supposed to rate them equally, right? Now, in such cases, we should be a little cautious about using, let's say, Cohen's Kappa as a metric. Rather, we should use something called as Mathew's coefficient correlation. Again, like it is a slightly advanced topic, so we'll not be covering it in detail. But just trying to give you a glimpse of the situations where your entire Cohen's Kappa concept could also go for a toss, and it might start painting a very, very wrong picture in front of you. Right? One simple thing or one simple metric, I think, which all of us can create to understand the efficacy of your entire AI system, or let's say to even understand the efficacy of your evals that you're building as compared to the human judgment, is to kind of create some kind of a confusion metric like this. So it has simply just 4 different sections, which is when LLM as judge basically said it is a pass, when LLM as judge basically classified the response as a fail, and when human basically passed it and human basically failed it, right? So these are the 4 quadrants that you basically got to get. Right now, for all of the responses that are actually coming to you, if human is also basically passing them and LLM judge is also passing them, there's no action needed. So if most of the responses that are coming out of your AI system is coming and basically sitting here, that means that like you have created a good kind of an AI system, and you have also created, let's say, a very good evaluation suite where most of the things are falling in this quadrant, and you're doing a good job here, right? But let's say if you end up in a scenario where humans are saying that like, okay, the response of the LLM system is actually good, right? But the LLM is just saying no, the response, sorry, when the human is saying that the response of the AI system is good, but the LLM judge is basically failing it, like which is this specific quadrant, right? What is happening is that your judge is becoming too harsh, right? It is unnecessarily, let's say, becoming harsh. And if you're really sure of, let's say, your human judgment, you should try and basically make the LLM slightly more lenient. It is actually acting more and more harsh. So you should look at that, like how have you defined the rules and why, and again, like say you have the reasoning, right, in the logs that like why it basically took certain decision. So you have to take the specific cases, understand the reasoning, and then fine tune the prompt accordingly, that like say how do I make it lesser harsher, and how do I, let's say, make it more fall in, let's say, in line with my human judgment. Now, the third thing could be that humans are basically scoring something as an AI response as fail, but your LLM as judge is basically passing this. Now, this is a situation where you would not want to be in, right? Now, from this situation perspective, at least what is happening is that your AI system accuracy is something which is not going for a toss, right? Because it is in reality, let's say, a good response, but an LLM as judge is not letting it pass it, which means like when a user is going to see the response, it is not going to see at least like a bad response. But in this cases, if you start completely relying upon the LLMS judge and starts passing something which fails as per the human criteria, what you ends up shipping is like a bad customer experience, because you're kind of giving a lot of outputs out in the open which are not so correct, and hence it might basically take the customer experience for a toss. In all of such cases, what you should do is that like you should try basically make LLM judge slightly more lenient, right? So sorry, what it says is that your LLM judge is basically more and more lenient, and it should start tightening the screw so that it starts falling somewhere either in this bucket or in this bucket. Most preferably, let's say, in this bucket. Now the fourth quadrant, right, which is probably indicating that your AI system itself is not capable, right? So again, I'm trying to connect the concept of capability versus consistency. If both of the things, like which is the human score and the LLM judge says that like, no, the response was not correct at all, and lot of your AI system responses are falling this in quadrant, which means that your AI system is poor. Either it is not even capable of doing the job that you're asking it to do it, or probably there is a lot of fine tuning that you need to do, let's say maybe in terms of the prompt that you're creating to generate those AI systems, or different interactions which are happening within that particular AI system you need to fix because it is not doing a great job at all. Okay, so this is like a simple confusion metric, which is very easy to plot, which is very intuitive. And I think everyone, like when we're trying to create any kind of an AI system on top of it, trying to create an evolve, we should create this kind of a confusion metric to understand that like what are the next areas of action for us, or if we are kind of happily living in this quadrant, maybe we can continue to live happy because there is no action that is needed from our end right now. I'll move to the next thing then. Probably this is the last topic in terms of theory that like we are going to cover, and then we will move to some kind of demos that like we have created for you. While you're trying to create LMS, I think you should also be mindful of the fact that apart from different hallucinations, there are some systemic biases which these LLMs have, and these biases are, let's say, very easy to test. You can understand that like whether your model is encountering this kind of a bias also or not, and you can report it, let's say, when you're trying to create the final eval report that you have. The first systemic bias is basically position bias. Now, what is coming out in different studies is that the LLM as judges, or LLMs in general, tend to kind of favor responses which comes higher in the order. So let's say I have two scenarios and I ask the LLM to say that like which response is better, which is basically response A and response B. It might so happen that like in scenario A and scenario B, like if the response does not even change, but I just flip the position of responses, where response A comes on the top followed by response B, and in the scenario B, response B comes on top followed by response A. It might so happen in these two cases the selection which LLM judge is going to make differs just because of the virtue of the fact that like which response is coming on the top. Okay, so this is something like which is basically called as position bias, and position bias becomes very dangerous when you are basically taking very close evaluation calls. Okay, so let's say between the two answers that we had, right, which is, let's say, response A and response B, if the answers were very different from each other, right? Somebody says that, let's say, the capital of India is Delhi, and this basically says that the capital of India is Mumbai. So definitely the response A is something like which is correct, right? It might so happen that like our position bias will not come at play because I mean, LLM is kind of also understanding that like what is the response coming out to be and how accurate this is, etc. But when, let's say, the evaluation calls are, let's say, very, very closer, right? Let's say it says that the capital of India is Delhi and the capital of India is New Delhi, right? The responses are, let's say, very, very similar. It might so happen that the position bias might actually come at play, right? It might not, but there's a greater likelihood that it might actually come at play, and hence you should be, let's say, kind of aware of the same. And how can you identify like if a position bias is existing, let's say, in a system also or not, right? So what you simply do is that like you shuffle the responses and compare. So you take out certain, let's say, sample data sets for you. You shuffle these responses and see that like what is the outcome coming out to be. If this is kind of a situation that you're arising, then you can report that like your LLM judge has a position bias. If it is not coming, you can simply say that like it does not have a position bias at all. The next kind of bias which comes like into these systems is basically the verbosity bias, where what happens is that LLMs tends to favor verbose answers irrespective of the quality, right? Again, just trying to take the same example of capital of India again, right? So let's say you're basically asking LLM as a judge that like which response is better. And the two responses that we have is that the capital of India is New Delhi. And the second response is that the capital of India is Delhi, which is located in northern India surrounded by the states of Haryana and UP. It is given, or it is actually found in research, that LLM might start, let's say, favoring these responses because it is more verbose, irrespective of the quality, because this answer is more correct than this answer. But because it was more verbose and it contains multiple other information also, LLMs will start kind of favoring the specific set of responses, and hence you should be aware about the same. Right. Now, when you're creating any kind of a, let's say, when you're dealing with any kind of a verbosity bias, there are also ways to kind of reduce that verbosity bias, right? What you can do is that, you can kind of give an exact instruction to your LLM, let's say in the few short examples, saying that do not prefer something because it is more verbose, and you can add certain examples. Maybe you can kind of add this example itself in a prompt saying that like this is not how you're supposed to act, right? And you can also start, let's say, doing some kind of a length-based penalty that like if like a response is coming out to be a certain is coming out to be, either you try to kind of restrict the response length itself, let's say from your AI system, or if there are certain responses which are coming out to be lengthy enough, you start basically putting a penalty, let's say, whenever an output is coming, so that like you're trying to control this phenomenon is still from happening, that like, I do not want a lot of long responses in my entire, let's say, output, because if I tend to give long responses, my judge is supposed to hallucinate. So this is something that like probably we will end, let's say, our session with, that like when or at least the theory part of it, that when you're kind of creating LLM as judge, it is not just required for you to say that like, okay, this is the accuracy of the system, or this is the accuracy which is coming out of the system. Whenever you're trying to, let's say, create an AI system, you should always kind of report the success rate with some amount of confidence interval. Whenever you're trying to, let's say, create any kind of an LLMS judge, you should not simply say that like, okay, this judge is kind of having an agreement with humans 70-75% of the times. Rather, you should start using advanced metrics such as Cohen's, Kappa, or MCCs, right? You should also try and basically kind of plot a confusion metric to give a very clear view to your stakeholders that like how this entire thing is performing, what are the places where areas of improvement exist, does not exist, etc. And you should also be mindful of the fact that like whether your LLMS judge is having any kind of a position bias or verbosity bias. If it does have, you should also report them as like, in your report card. Okay, so this is, I think, what we had to cover from a purely, let's say, concept perspective. If there are any questions, happy to answer them. If there are none, maybe we can take a 5 minutes break and then we can start the demo part of it.
Yeah, Apur, it will be good. Like if you can summarize, let's say in the last, like whatever we have discussed in, let's say 5 minutes, that will be great.
Yeah, sure. Sure, Shailesh, right? So far, I think in this session, what you will be able to learn today is that why your AI systems are very different than the traditional systems that the software world is actually full of. So these typical systems that we have are very deterministic in nature, but the moment you try and bring AI into the equation, the entire system starts becoming very, very non-deterministic. And either it might so happen that for a single output there could be, let's say, multiple answers which could be coming, right? We also talked about the concept of capability and consistency, where we understood that, like, say, how can we use recall as k, how can we kind of use pass at k and reliable at k as a metrics to understand if your model is if your AI system is even capable or not, and if it is capable, what is the gap between the capability and the consistency. Then we spoke about different kind of evals that we have, let's say, in the system, which could be, let's say, a code-based eval, where you start using it where the problem is very deterministic, and you have already, let's say, very simple ways available to kind of detect and solve them. Then you start using something called as off-the-shelf ML-based models, where you have slightly, let's say, non-deterministic problems, but these are slightly generic ones which are already solved, let's say, across the different use cases, where you have, let's say, something called as sentiment detection, PI detection. You use any off-the-shelf model from, let's say, Hugging Face, etc. And then you have the third category, where you have, let's say, something which is a more complex set of problems, which is normally solved by LLMs judge, where you start, let's say, looking into consideration that, like, okay, the problem is also very non-deterministic and it is very non-generic also, such as your handoff issues, such as your out of the scope issues, where you start using invoking LLMs judge. Then we kind of moved further. We also talked about the concept of that, like, okay, if LLM is acting as a judge, what is the reference to the answer? Does the LLM has to kind of refer to certain kind of a ground truth, or it's like a completely the world knowledge that it has to kind of rely upon? So we discussed about the cases where a reference-based evaluation and where a reference-free evaluation has to be used, in what cases it should not be used. Like, is there a kind of a possibility of having a hybrid kind of a system where you have some portions of reference-free evals, some portions of, let's say, reference-based evals? Going forward, we also discussed about, say, what is a trace, like what does a trace actually represent, what are the kind of decisions that you can take from the trace, that like what are the different steps that the model takes, what are the steps, let's say, where which is consuming, let's say, the highest amount of tokens, what is the step which contains the highest amount of, let's say, latency, etc. How do you kind of resolve the same? Then we also spoke about at length about that how do we do the trace analysis, where we spoke about that the first set of traces needs to be, let's say, read by an SME, and then like we have to do an open coding on them. We should always use a binary scale. We should never use, let's say, Likert kind of a scale while doing this trace analysis. And once we have the open codes ready, how can we use an LLM to kind of convert those open codes into actual codes? And then we also spoke about the fact that, like, how do I conclude my trace analysis, that I need not how do I kind of reach a state where I'm very sure that like I need not read any more traces? So what do we do there is that like we simply kind of plot and we simply kind of try and understand that like if I read more and more traces, am I encountering any newer kind of an issues? If I'm not encountering any newer kind of an issues, which means that I've already reached the saturation and I should start focusing on building LLM as such rather than kind of reading more and more traces again. Okay, then we also kind of spoke about that. Okay, if you have created an eval system and if you're finding that like your accuracy is coming out to be 65%, is that 65% accuracy even correct or not? How do we let's say be more and more sure about it by kind of reporting it with, let's say, along with some kind of a confidence interval. And we also spoke about the fact that you should start go and basically measure this accuracy across different segments of the queries that you have, because the segments of the problems that your AI system is going to face could be ranging from, let's say, very low complexity, medium complexity to high complexity. So whenever we are trying to understand the performance of our AI system, we should also take in mind the segments into consideration. Then we also spoke about something called as that, like why that if there's a variance which is coming out, let's say in the overall efficacy of my AI system, what part of it is could be coming, let's say, from LLMS judge, and if it is coming from LLMS judge, how do I kind of go and eradicate the same, right? Which is by fine tuning the temperatures parameters. Then we spoke about the concept of Cohen's kappa, where we said that like if we are able to understand that like your LLMS judge is kind of competing or is kind of, let's say, benchmarked against a human evaluation, what is the agreement rate coming out to be? We also discussed that simply saying agreement rate is 70%, why is not always a good thing, because this agreement could also be purely because of chance or chance, etc. Then we also discussed about that how can we include let's say Cohen's kappa into the equation to figure out that what is the actual agreement, and what are the cases where even Cohen's kappa could actually go for a toss and you should then rely upon something called as MCC, etc. I skipped one part. I think we also evaluated in detail that like what is the RAG for evals look like, and what are the different metrics that it should kind of cover when you're talking about RAG based evals. We specifically spoke about the metrics which is precision at K, recall at K, and MRR, and we specifically talked about the cases where each of them starts becoming very, very important. For example, precision at K is important in cases where your model itself has a very, very low context window, typically in the case of on-device models, etc. Recall at K becomes really important where you're trying to take a decision which is very high stakes. For example, any kind of a medical chatbot that you're building, or any kind of a, let's say, any kind of a legal chatbot that you're building. And we also spoke about the case of MRR, which becomes really important, where we say that like, okay, it should not be just the relevant documents that we are fetching, but the position of the relevant document also matters. And this position should always, let's say, come on the top. And we spoke about the cases in case of your search queries, or let's say in case of a shopping chatbot, where the results against the user query are retrieved and shown to the users, right? And in the end, we also spoke about that, like what are the different kind of systemic biases your LLM could have, LLM judge could have. We spoke about two different kind of biases, which is position bias, which is nothing but, let's say, if I flip the positions of my responses, like does the response of my LLM judge changes? What we kind of discovered and learned is that in case there's a very huge differentiation between there's a huge difference, let's say, in the two responses, then the position at bias might not come at play. But when the responses are very closely similar to each other, the position bias might actually start coming into play. We also started to learn about something called as verbosity bias, where we said that like irrespective of the quality of the response, if the response is verbose enough, LLMs tends to kind of prefer those responses. And we also learned about the way that like how should we kind of handle this verbosity bias by adding, let's say, few short examples in the prompt, by limiting, let's say, the response length itself, let's say, of our response that is coming by the AI system. So this is, let's say, what we have learned. We have started from the scratch, where I think we started to establish a condition that where we started to establish the understanding that like how a deterministic model works. We understood the challenges of the non-deterministic model. We understood that like what are the different tools that we have to kind of handle those non-determinism in the system. And then we kind of deep dived into LLM as judge. How do we kind of create one? How do we kind of build one? How do we analyze one? And how do we ship one? And what is the kind of overall report card that we have to report for LLM as judge, and which is right now what is present, let's say, in front of your screen. So I think this is, like, say, what we were able to cover, let's say, in the last approximately 2.5 hours. If there's any question, happy to take them.
Yeah, so I have one question, basically, and I'll try to frame it because there are a lot of thoughts going on. But The question is basically, let's take a scenario where we are creating a summary of a doc. Okay. LLM is creating a summary of a doc that exists. Now, I have to create an evals pipeline, let's say for quality of that doc, right? Now, there are two, like, there's some confusion, and I'm also trying to connect the dots. So, one is reference free eval and one is reference based eval. Now, if I have to evaluate that pipeline, there could be 5 6 criterias that I will evaluate it. For example, groundness, which means accuracy, all those things, right?
Yeah.
Now my question is that the card that you had shown, right, it's more
Yeah.
based on the quality of LLM as a judge, right?
Yeah.
But
Yeah.
where will, let's say, the coded thing come? Because right now I'm getting confused. Let's say if I have to measure groundness, right, I have a reference for it. It's something that I can quantify it, right? And let's say like, I'm just thinking of an example where it would be like, I do not have a reference, and then so I'm just trying to see how would that fit in a pipeline basically. Is
So
like,
essentially, what you're trying.
yeah,
There's
sorry,
Yeah.
sorry, go
Yeah.
ahead.
So essentially, I think what you're asking is that, say, we now understand that, like, say, what are the kind of reports that we have to create when we are creating LLMs just. But if my AI system itself is at fault, right? Say, how do I kind of even go and establish the same? That's what you're trying to answer, correct?
I mean, yes, that's also there, but I think this part also, that how do I fit these pieces in for like a automatic eval pipeline, and like where does the reference part come in, and where does the free, or I can take some time and then get back to you with like this question.
That's okay, but I'm just trying to probably answer that, right? So just trying to basically paint a scenario that, let's say if you're looking at the responses of AI system, and let's say the success rate is coming out to be 65%. What it basically says is that, like, there is, let's say, a 35% probability where it is not doing a good job. Let's say maybe it's not able to do the job of summarization because of whatever reasons, right? And then you can also basically have your LLM as just accuracy pasted on top of it to understand that, like, okay, the 65% good responses that I'm getting, right? What percentage of it could be, let's say, right, could be wrong, because my LLM as judge itself might have a variance, right? So you should always kind of look these two metrics, let's say, in tandem to kind of answer this question. Whereas the first metric, which is the accuracy of the entire system, tells you about that, like in what percentage of cases it is performing good, it is not performing good. The later part of it kind of tells you that, like, okay, what is the reliability of this accuracy that I'm reporting, because it is not judged by a human, it is rather, let's say, judged by LLM as a judge.
Makes sense. Okay, I think this answers, but I have one more question. I'll get back with
Sure.
the structuring.
Yeah.
Any other question? Or we can, I can directly go to this one. Let me share my screen. Yeah. I hope my screen is visible. I'm also audible, right?
Yeah, Shailesh, go ahead.
Yeah. So what we have done here is, let's say, whatever we discussed in the theory, we are trying to simulate that in terms of, let's say, one of the demo. It's not a real chatbot because we have not done it. We have not deployed it. So what we did is, like, we are mocking the response of the data from the chatbot. So what we did is, let's say, we just imported some of the libraries, which will become very important in our evaluation and all. So what we first step is we mock the data. What are, like, here I have used, for example, in the real case, you would get a lot of example from your own log events table, right? You will be getting that data from the events table, get the what is the input, what is the output your system is giving, right? Here what we did is, like, we just give the mock data so that we can understand, like, we can evaluate. So input something like, can you recommend a blue running shoes under 100? And this is the typical output which the model is giving, right? This is the mock data we have done. So first what we'll do is, like, we'll set up our data frame, right? Because we don't have the live chatbot, we will just set up the data frame here. Let it run. Yeah, so it has run. Our data frame is ready. What we can do is like we can also print our data frame, but we are not doing that. Then after that, what we are doing is like we are loading our data frame into level one JSON, level one eval. So what we checked was the output which we were expecting in terms of JSON. Why it is important? Because whenever your LLM is giving the output, if it is in a JSON format, it is very easy for a software engineer or a backend engineer to put that JSON format in terms of a UI to the user. If it is not, if it is a free flow text, again, you have to put another model on the top of it to extract the right amount of the data. That is where the first level of eval we will see what it is. Like we are just checking if the response that is given by the AI system is in the form of JSON or not. So we'll just write a small code. So what it is telling is, let's say the first response which is given by LLM is in the JSON format. So we have passed the let's say code based eval. But the second output which you have seen, the crimson tracker, is $120. It's a great boot. It's a free flow text. It is not coming into a desired format of your JSON. That is why it is giving you a 0, right? So in this system, any complex system, you would be having a multiple hybrid eval. It is not that you will be just using a code-based eval or let's say ML eval or let's say LLM as a judge. You will have multiple. It's a basically hybrid system, right? Because I'll not be using a LLM as judge for a very simple task. It's a very simple and deterministic task. That is why I have used a code-based eval, right? So here, this is the response we have gotten. So every time the system is giving me, or the chatbot is giving me a data of, let's say, a normal text flow, I am just flagging it 0. Now the second one was the ML based eval. So there are a lot of machine learning model which is out there, right? Like over the course of 15-20 years, every e-commerce platforms are building a lot more like different type of their ML models. Some are open source. For example, there are n number of open source model you will be finding for, let's say, your sentiment analysis and other things. So what we can do is like from the you can just import those kind of Hugging Face or ML model from this library. What we have done is like we have just exported that, let's say, the library, and we are creating a pipeline, and we are just calling a function of toxicity judge. Basically, what it says is, let's say, out of how many responses which the LLM, like your AI system is giving, like, is it toxic? Is it not toxic? So it is like slightly like it is importing the model, and we'll see like what is the response it is coming, right? It will actually tell, let's say, whether the particular output from a chatbot is a let's say a toxic sort of thing, or is it under, let's say, a very let's say normal conversation which we expect the any output system or any, let's say, the chatbot system to work. Is it run?
Yeah, it's running.
Okay, fine.
Yeah.
Yes. So what we did is like we have like imported all the models, like the ML model, which is supposed to run all your toxicity analysis, sentiment analysis. So for all the output which we have created, the demo data, it is exactly tell, let's say, which of this is pass, which of this is no. So if you see the third output where the system, the shopping chatbot, it is saying like, I am sorry, I feel the way. Can you go up, Apur, at the first where we created the data? Can you go up to the third one? Yeah. So if you check the third input, the output which the AI shopping assistant is saying, I am sorry, you feel that way. You are idiot. I cannot help you, right? Because this is not the way your LLM or like any the shopping chatbot should give the response, right? Go down. That is why this ML model has flagged it to, let's say, a 0, right? And other response are in sync with, let's say, whatever the shopping chatbot response should be. Now go down. Here, what we are doing in the fourth step, we are importing, let's say, OpenAI. We are creating a prompt. We are creating basically LLM as an eval, right? What you need to do is like if you run this in your production environment, get the set of the key and then paste it here and call the real LLM. Like here, what it is saying is, let's say, like the response, the fourth response is it is basically telling it to 0 because the watch which exactly the user wanted, it is not a waterproof watch, it is basically water resistant watch, which LLM is kind of hallucinating. That is why your let's say the level 3 the LLM as judge output has flagged as a false. Go down. Then what we did is like we'll create these set of metrics, right? So in the technical integrity where you expected JSON to come, it is a 50% because on the 2 times it is not giving you JSON response. Brand safety, the toxicity, the kind of response which you should get from LLM eval, it is 75% because in one case, the tone of the shopping assistant was not good. In terms of fourth, when there is a LLM as a judge, we have evaluated it's a 75% because that watch exactly which the input was, it was asking a water resistant watch, but the watch what was not like a water resistant, right? This is what we did, like a 3 and plotted the accuracy go down. Yeah, this is the report. Yeah. Then we are what we have created is, let's say we have created all the metric where out of all the responses, it's a mock response we have created. So out of all the responses, like is LLM is judge saying, let's say it's a good, and what human saying it is a good. If that is the case, then it's a very good chatbot, right? For example, judge pass and human pass. That's a out of 10, 5 responses are something like this. That means it's a positive sort of response. But in case a judge is failing and human is passing, that is one, or human failing, judge is passing, that is one. That is something which we need to tweak your eval prompt, right? And in case your human is also failing, your judge is also failing, those are the 3 cases where you need to improve your shopping assistant only. It's not a problem of eval, it is a problem of entire prompt which you have written to create the shopping assistant, right? This is what you need to exactly track. In a real production system, you will set this kind of pipeline every week or every bi-weekly, or let's say every 5 days, this sort of pipeline will run. You will see the set of issues. Accordingly, you will take the next set of action, whether you need to improve the prompt of the original AI assistant, or you need to improve the prompt of, let's say, AI eval, or you don't have to do anything, right? This is the complete pipeline which you need to build in case of a real production system. Like any question onto this. So here we have gotten, let's say, Cohen's and Kappa score, observed accuracy and everything, right? And based on that, like we have gotten, let's say, a recommendation whether you need to ship this product to a real user or not, right? Any question onto this?
I have one question. So we have 3 different types of judge, right? One is based on like it's not the same judge, correct? Like
So there
so.
are 3 evals, not judge. Judge is, let's say, LLM as a judge.
I
Second
mean,
is the first is code based. Second is your ML based, and third is your LLM as a judge.
but we want to evaluate code because we are running a model. So we want to make sure that that model is also predicting it correctly, right? So we are mapping that to here, right? So that will come under the judge. I'm getting confused there. If how are we make LLM as a judge, we mapped it, right? But for the code based or other 2 models, we'll put it in the judge category. We'll treat it as judge, right? Or no? Or
So judge as in, let's basically these are like 3 different evals we are getting the score from. Like don't get into a terminology like whether we are calling a judge. It's basically an idea to validate whether your shopping assistant is working fine or not. It's a type of eval.
okay, yeah. But I'm not getting the mapping. I think I got confused.
Mapping isn't like what mapping?
This like, okay, when is it a pass, when it is a fail? Like, because you have 4 questions, you're running
No,
3 evaluations.
no. This is a mock data. This is not the data which you have used above, right? This is a go above. Yeah. This is a I have mocked the data where human label and LLM label, right? It's not like the same response because we don't have human as a judge right now, right? Yeah, that is why I have just mocked the data to represent how to calculate this Cohen's and Kappa and everything score. But it's not, you cannot link that to the first 4 responses.
And okay, I am somewhere not able to tie it up, but maybe I'll ask you later. I'm not. I'm getting confused.
So what I'm saying is 10 responses are mock responses. There is no relation with the 4 input and output we have given at the top.
Got it. So when we are mapping it, we are not checking the response from those. That's independent.
Yes, because I don't have that kind of real prediction.
Understood. Okay.
That is, I just mock it.
Got it. So I thought it's also mapping the like the responses from the models as well.
No, that is not there.
Okay.
Yeah. Any question or any final thought? I think like we are near to the time itself. The recording will be available. Let's say those of you who opt for recording, you will get the recording. We'll also float let's say a completion sort of certificate, like we'll mail you. Yeah. Okay, so if there are no other question, we can close the call itself. Thanks everyone. Like we'll be having more sessions like this. We'll going into deep of model selection and like other advanced topic in AI. Yeah. Thanks. Yeah.
Thank you. Thank you, everyone.